for the session on Big Data and Hadoop, and my name is Vishal. I'm going to be your instructor for this entire course on Big Data and Hadoop. And again, thank you. Thanks a lot for choosing Skillspeed as your knowledge partner. We'll see in this session we are going to have the introduction of Big Data and Hadoop, and since this session is going to be the first one in the series of 10 such sessions, so there will be some one-time things which we'll be covering. So just want to reconfirm once more whether, because more people have joined in between, so whether all of you are able to hear me or not clearly. So though Shubham has confirmed, what about Aditya, Sandeep, Raja and others? I hope all of you are able to hear me properly. Great, great. Thank you. Thanks for confirming. So let others to join us, but in the meantime we'll just continue with our class, because there are, since this is going to be the first session, there are some one-time activities for this class. We'll start with it. So before we proceed, let me just introduce a bit about myself. My name is Vishal, and I'm having overall around 12 years of experience in industry, and typically that experience goes towards retail domain and finance domain. There were some projects in the telecom and healthcare domain as well, which I have done, but again they were like pretty small sort of projects. When it comes to big data domain, so it's going to be almost, I think, 5 years now when I'm working in big data domain, and the exposure goes towards the technologies like Hadoop, Spark, Storm, and a bit of Mahout as well. So the when it comes to the specialization in big data world, so typically the application of Lambda architectures and all, that is something which is kind of my acquired, I would say, specialization over the period of time. When it comes to the different kinds of clients for which I have worked, or probably the companies with which I have worked, it is my career started with Oracle, and then have moved on to Citigroup, Sears Holdings, and there are few more others which are the clients in different domains with which we have worked. So I think that is pretty much of it about myself before we go ahead and start. The course topics, before we actually start on the course topics and things like that, it always helps if we just get a bit idea about the class as well, about the people as well who are attending it. So I would really appreciate if you guys could introduce yourself, probably just 2 lines about, of course I can see your name, so the number of years of experience which you are carrying, the area in which you have worked, either functionally or technically, and if at all you have some big data experience, are you carrying some experience with it or not. That really helps us in 2 ways. One, it helps as an icebreaker for the first class, yes, but the greater purpose which is solved out of this is we come to know your background, and through accordingly we can just customize our coverage accordingly, right? So that really helps. So guys, I will highly appreciate if you could just type a bit about your experience, about the name and experiences with whatever you are coming to us. So let's start. Aditya, Raja, Shubham, Varun. Hello. Okay. So people are typing. That's fine. I was a bit worried whether Okay, so Shubham says that he is, hi Varun, good morning. I think you just joined. So we just started this session, and right now we are into the introduction part of, I just introduced myself. My name is Vishal, and you can see the recording as well a bit later. It's about my experience which I just shared. Now I'm just asking your background, kind of. So, you know, from which background you people are coming and whether you're carrying some big data experience along with you or not. That really helps us to decide the depth of coverage. So I would appreciate if all of you guys could type it. Shubham says he's having around 8 years of experience and total experience is in telecom. Wow. And PSS domain. Okay. And sorry, I don't have any big data experience. No, you don't really need to be sorry about that, Shubham. And by the way, telecom is, you must be aware, telecom is one of the very natural contenders of big data domain application. We will talk about that in depth because today's class is all about introduction to the big data world and the introduction to Hadoop ecosystem and all. So at the same time, we will be talking a lot about its implementation, various areas in which it is implemented. At that time, you will see that. In fact, I'll share some of my experiences with some of the telecom projects. Okay, so here is Sandeep with us. So Sandeep is having around 6 years of experience in supply chain. So when you talk about supply chain analytics or supply chain processing sort of applications, and Java, first time to big data domain. So Sandeep, you know what? The best thing which you are carrying is number of years of experience is fine, but you are having the experience in Java. So that really helps when you are venturing something in big data domain, and especially if you are venturing something in Hadoop, because Hadoop is written in Java. Okay, so it's going to be quite exciting to you as well. Raja is having around 5 years of experience in Teradata and 6 months in Hadoop. Okay, so that's good. So you just started your journey in Hadoop, right, Raja? Right, and you are coming from data warehousing domain, so I am assuming, if correct me if I'm wrong, you might be using Hive or something, right, in your company. Listen, Hive or bit of Pig or something, right? Hive and Pig, right? See, that really helps, right? The moment you told me about your experience, I could easily deduce what exactly are the kind of tools which you might be exploring. So yep, that's going to be exciting, and I can see that people are carrying different levels of experience with us. Aditya is having around 2 years of experience in .NET and core Java technologies. Wow, that's quite diverse, seeing the 2 years of experience. And I'm more into the web development but have no past experience in Hadoop and big data domain. Not a problem, Aditya. And that's the reason we are here, isn't it? That's the reason we are here. Okay. Varun is having around 3.5 years of experience in Siebel CRM, okay, around financial service and public sector domain. Nice. Okay. So I also like to add that my total experience in core Java. Shubham, are you typing something? I hope you are. So great. Okay. So overall, as I can see that, yep, I think there are more people who are going to join us, but let's, have their introduction as in when, we'll be going ahead in the class, or somebody or else would be asking their doubts and things like that. So we will definitely be talking about all that part. Okay. So I think, yep, Sohil just joined us. Hi Sohil, good morning, if you are able to hear me. Okay, so I think Sohil just joined. Good morning Sohil, if you are able to hear me, could you just confirm? Okay, by the time he confirms. So I was just on the part that based on this entire ice-breaking session, I would say. It gave me as well as all of you also a very good idea that we are having a diverse audience here. People with almost 8 years plus experience, and then there are some people who are just starting their career or probably have just started in the early phases of their career, right? Like people are having some 2 years of experience, 4 years of experience, and then there are people with 8+ years of experience. That's quite good. There are some, so almost all of the class doesn't have the big data, or when it comes to that, Hadoop kind of a background. There are some people who have just started exploring big data world due to whatever factors, probably due to the practices, whether they started in your company or something like that, and then are venturing into this. So all I would just say at this point of time is this entire course is definitely going to have each and everything for people with different backgrounds. Okay. And how am I going to cover that, or how am I going to relate all of this is in this particular slide. That slide where I'm going to talk about course topics and things like that. But before even I come to this part, there are some of the basic, I would say, some of the basic approaches for which I would like to take the opinion of the class itself. Okay, so guys, simple thing, when we are discussing about the topics, definitely questions or doubts are quite natural. If they happen, that means we are learning something, right? Now, there are two ways to answer the questions, right? One, you had a doubt, you raise the question then and there itself, and we'll try to answer it there itself. But the second approach is, you have the question, you keep putting it in the question tab, and let me answer those questions at the logical conclusion of a concept. That second up, so these are the two approaches. Any approach is fine with me. I would leave it to the class, and I would like to take your responses in kind of, in the questions tab itself, which approach looks good to you. Personally, in my experience, I have seen that second approach works well, because what happens is you are asking a question right now, which might be answered within, let's say, next few minutes, right? I might be explaining the other concept. That is one. Then the second thing is, we can batch the similar kind of questions as well, because let's say one question which is asked by Aditya and the other question which is asked by Varun, both are same, right? So batching of the similar question, and overall it results into the higher speed itself, right? So there are lesser interruptions in the broadcast which you are hearing. We are not in face-to-face mode, but you are listening it from remote mode. So the flow also is not, obstructed. But again, I would leave it to the class. So Aditya has said second approach. What about others? And we encourage interaction a lot in this class, especially it being the remote one. So I encourage, or sometimes I force also people to type it. So that is one. Sure. Shubhram, Aditya. What about others? Raja, Varun, sure. Thank you. Sohil, Sandeep, I am hoping that you are also listening, and probably it is just the matter if you're just trying to find out the question tab. Okay. Thank you. Thank you, guys. The other part is, I think the last part. So sometimes what really happens is, typing your question might just not be feasible, right? Or probably what happens is you're typing something, but your context of the question might not be so clear. So in those tricky situations, my typical approach is, I typically unmute the person, and then we do interact as if you are interacting in face-to-face kind of classes, and that really helps us to resolve the query much faster way. So I highly encourage all of you to have your headsets and microphone ready in the classes, just in case if it is required. And from the second class onwards, so since today is the first class, I'm not going to spend that time today, but from the second class onwards, our first section is always going to be Let's Revise, wherein that's the best part, where the instructor, Vishal, does not speak much. It's you people who speak at that point of time. So it will come quite handy. Okay. With that, the last thing is about, since it's going to be 3 hours of duration, so it is difficult for people to have the consistent attention, right? So based on previous experiences, people typically suggest a break in between, though personally I don't prefer it, but still. So we would typically have a 5 minutes break at the mid time at 1.5 hours roundabout, or somewhere logical point, either 5 minutes here or there. So I hope that should be fine. Please don't ask for more than a 5 minutes amount of a break. I hope that should be fine with everybody, right? Great. Great. Thank you. Thank you for confirming, guys. Okay, so let's just get started now. This is actually, I would say, the real start of the course now. So guys, I just took the kind of inputs from all of you about the backgrounds with which you come, about the expectations which you would be having. So your backgrounds sometimes tell your expectations automatically, right? So let me just introduce the course to you, the coverage and the things which we are going to cover. So guys, overall course is divided in 10 different modules. Every module is of 3 hours duration. Okay. The first course, which is the first module which is happening today, it's the, I would say, the easiest and the most theoretical one, because from module 2 onwards and barring module 8, wherein you will have substantial theoretical aspect, there are a lot of concepts, but barring module 1 and a bit of module 8, you will be having consistent hands-on sort of sessions. Okay, so the first session we are going to talk about big data and Hadoop. The reason for all of us to be assembled here, why exactly we are attending this class, right? And why exactly we are even attending this entire course, right? So big data and Hadoop have become almost kind of keywords in the industry sometimes, and you must have heard, either you are coming from different companies or probably you are exploring it on your own, right? You are definitely exploring it because you would have definitely heard that it's kind of a, I would say, these have become kind of buzzwords altogether, sometimes like a jargon. So we would like to demystify some aspects of it in the module 1. Module 2, which will happen tomorrow, right? We will be going into the details of one of the core components of Hadoop ecosystem, that is called HDFS, Hadoop Distributed File System. And that would be the time when we'll be seeing some, kind of a small hands-on part of it. We will be seeing more about the configuration files. So what exactly are the different configuration files? I would not say that all of the configuration files are related to you, because you anyway are the developers, so you don't really care much about the configuration file. That is more of the admin stuff. But having said that, it really helps when, let's say, you're trying something on your own, right? You're trying something on your own system, then it really helps, because typically in companies and all, your admins do configure these things for you, but it is good to know. And the last part of tomorrow's session is going to be the data loading part. So Hadoop and all, very soon you will find out. It's very good for data exploration part, data processing part and all, but how do you even bring the data in Hadoop, right? So data loading is a very important part. Depending upon the kind of data source with which you are dealing, you might be having a different data loading technique. So that will be the focus for tomorrow. Now, this would be the first week. The second week is dedicated for MapReduce. And guys, let me tell, due to some reason, if you have missed the first session, that is fine, because you might be having some background already in big data world, or probably you might have heard a lot about it. That's fine. But the second week, module 3 and 4, please at any cost try to attend it, right? Don't miss it at all. This is about introduction to MapReduce and the advanced MapReduce concepts. So I'm not really sure whether all of you or some of you have attended the webinars which we had before the classes. Uh, these two modules are going to form the basis of all other modules which are going to follow. Okay, MapReduce is a paradigm. It's a way of calculation, calculating the things, right? So the module 3 is going to put the foundations of it. The module 3 is going to talk about what exactly MapReduce paradigm is, what exactly does it take to express your problem in a MapReduce way. So I hope people understand the meaning of a paradigm, right? It's like you can solve the very same problem using SQL, and you can solve the very same problem using a simple Java program. These are called two different ways of solving the same problem. Similarly, when it comes to a MapReduce program, it is a third way of thinking, right? So SQL guy typically thinks in the terms of tables, structures, relations and all, whereas a Java guy typically thinks in the terms of data structure, the kind of control structure, looping, or if else conditions and other stuff which they are going to put. So they are different kind of paradigms. Similarly, when it comes to MapReduce, so MapReduce does not have to do anything with the programming part itself. MapReduce is more of a algorithmic side, right? So module 3 is going to put the foundations of it. Guys, please make sure that you attend this, okay? Because whatever we are going to do next, they might just be the wrappers around module 3 and 4, okay? Module 4, so module 3, when it was about the basics, module 4 is about the advanced part, wherein some specialized situations. So now you know how to express your problems, but in practical world, because Skillspeed courses are all about industrial implementation of your concepts, right? So now you know how to express your problem in the MapReduce world or MapReduce fashion. What if, let's say, you have a very unusual kind of data distribution available to you, right? What if, let's say, you just don't want to process your data, but you just want to get some sort of profiling of the data, right? I'm just giving you some examples, right? So if I'm sure, especially the people who are carrying higher years of experience can easily correlate to it. When you are having a huge amount of data, sometimes you don't really want to process it. You just want to make a sense of it. You just want to profile it, right? So these are some of the scenarios. How do you really do them in MapReduce world, right? Or probably, let's say you are having some sort of sequence files, or for that matter, many such scenarios, right? So how do you really process them using MapReduce? That would be the part of discussion in module 4. Module 5 is especially going to be useful, for people who are like I think like Raja, if I'm correct. Raja, forgive me if I'm wrong about this part, who are using or who are just new to big data world, right? And who are either using Hive or PIG for the data exploration perspective. In all, what I'm trying to say is people who come from the data warehousing kind of a background, okay? Though, let me explain right now, PIG is not a data warehousing package. PIG is the data flow language of Hadoop. Okay, so what exactly a data flow language is, and how do you really think in the term of data flow? Let's not talk about language right now. PIG is a very simple language, but what exactly a data flow is, how do you start thinking in data flow manner itself? That is something which will be very important. And then it is the application of PIG, or I would say application of the data flows in PIG script, right? How do you really write the PIG scripts and other stuff? That's going to be very interesting. Module 6, again, just like we are following the very same pattern. Then apart from basics, then module 6 typically talks about the advanced parts of it, wherein you might not just like to work with PIG, probably you would like to extend it, like people who are from Java background and all, you want to extend PIG to Java, you want to, let's say, interface PIG with something else, right? So this is going to be very exciting, wherein we'll be talking about all those advanced aspects. Especially people who have spent some time in PIG will find it very relevant. Okay. Now, module 6 almost half, and module 7. Anybody who is from data warehouse background, anybody who has done ETL operations and other stuff, basically SQL kind of exposure, and is or are attending these sessions, please do not miss these two. They are just the ones only for those people. Rather than saying only, they are focused on those people. Others, of course, are going to get the benefit of it. But guys, what is, if I ask you, so Raja, you can answer, and others, others are also free. You are coming from SQL background. What is the biggest hindrance for you when you come to Hadoop world? What is the biggest hindrance which you face? Rather than me talking about it. Raja, others, the first thing which kind of, creates some limitations for you right now. Any responses, guys? I highly appreciate if you could just type. And then I'll tell you what exactly is the focal point there. Anybody? Sohil, Raja, Sandeep? Okay. Reading the data, that's fine. No. Atul, okay. Subram, there is one more thing. Length of code, yes. Probably Raja, you are somewhere on the line. Now tell me one thing. You are from SQL background, right? If I ask you to write a MapReduce program, let's say even if I explain you what exactly MapReduce paradigm is, right? Writing it in Java makes your life a bit difficult, isn't it? It's not because Java is difficult. It is just because your background is different, right? And it is true with everybody who comes with the ETL background, right? So that is very, very important part, right? That you are coming from a different background, wherein it makes your task a bit more difficult. So the thing is, you know SQL part of it, but you don't really want to write MapReduce programs, right? Hive is the right answer for those people who, let's say, typically want to do structural data analysis only, right? But they are not really interested in writing MapReduce programs just because they want to do some, let's say, some sort of structural data analysis itself on a huge data set. So they don't really want to write MapReduce just to do that. And Hive and Pig were developed exactly for such kind of people. Okay, so they give you a chance to leverage the processing power of Hadoop without knowing the those nitgrit, basically the internals of MapReduce concepts altogether. Okay, so that is very important here. Okay, so these things are going to be very useful for you. Okay, about this module 6 and 7, and module 8 goes into the same thing. So extending Hive, just like the we extended PIG, or we'll be talking about extending of PIG and all. We'll be talking about extending Hive, and then HBase. HBase is, especially those people who are coming from Java background, is going to be very useful. HBase is sometimes called the database of Hadoop. Okay, so why is it called so? What exactly are its advantages, disadvantages, and things like that? That would be the concept between 8 and 9. And 9th module, we are even going to talk about Uzi, which is the workflow. So by now you would have definitely learned about different concepts or different kinds of tools when you are preparing the solution. So how exactly you are going to create a workflow of them. That this particular part, Uzi introduction, I'm not really sure of how many people would be using it in production, because like I'll tell you from my own experience in my previous companies and all, companies used to typically pay the vendors for their schedulers. They used to get the licenses, and then there were company-wide policies. So I had to use specific kind of schedulers like IBM Control M and things like that. But there are various organizations who are quite open to, let's say, go for the new kind of schedulers. So in that case, Uzi is going to be very useful for you. We will see what are these capabilities and all. Okay. So, and then module 10, which is last, it is about the project setup discussion. So module 10 is the fun one, wherein we don't really, okay, where we don't really talk about any concept. It's like I would be preparing a problem statement, which will be, what I can assure right now is going to be the similar to the one which you or somebody else is going to face in your organizations. And then the class would turn into a project discussion forum, wherein you people would be coming back with the solution. I would not. That's going to be fun. And we are going to discuss different solution approaches. This is going to be fun, and keep your headsets and microphone ready for that class. We'll talk about that later. So I'm not going to spend much time about it. Guys, looks good to all of you. Raja, whatever I just talked about, SQL part, processing part of it, and MapReduce and other stuff, makes sense? Can we just go forward for this session and the other details which we are going to cover? Right? Guys, quickly, if you could just reply. Raja, Varun, great. Thank you. Thanks for confirming, guys. Okay. So this session, now we'll just come to the exact this session. So there were those people who have just joined us a bit later. There were some one-time activities which we had done. So introduction, and we just talked about the kind of small things which we'll follow. So please, I'm not going to repeat them. You can always refer the recording for that initial part. I'm just continuing with the objectives part of it. So the first thing is, the first focus point I would say is what exactly this big data is, right? That is something which is going to be the focus point for the first and the foremost thing. That's one of the reasons due to which even the Hadoop started. That's one of the reasons due to which probably systems like Spark, systems like Storm and other things are starting, right? So what exactly it is? What are its different aspects which make it challenging, which make it hot, which make it highest paying kind of industry, and among the latest technology trends and all, wherever you will see big data, at least in top 3 kind of thing, right? So what exactly are the things? It cannot be there for without a reason, right? So what are those reasons and other stuff, right? So basically that forms the second point. List the challenges associated with big data, right? Those are the things which make it very exciting. Then we'll be talking about, so big data. Now this is a term, right? Whether it is big or whether it is kind of, you talk about your traditional amount of data, you are going to process it. Why are you talking about data? Because you are going to process it. You are going to process it and then get the information out of your data, right? So based on various aspects, your company or you or your project may decide to take an approach. Either you would like to process the data in batch, or you would like to process the data in real time. So what exactly the batch processing is, batch analytics is, real time, and what are the nuances of each and every approach? Now, on the top of it, when you do it in the big data world, right? So there are two things, all those people who are, like we are having some senior people also, right, in this class. So they definitely must be aware of big data, or rather than big data, I would say real time versus batch processing. But what exactly are the additional challenges when the real time processing application or the batch processing application is applied in the big data domain, right? So the definitions slightly change. The boundary conditions change slightly there. Okay, we'll talk about those aspects. And then the last two parts. Remember, for the first 3 points, I'm not going to talk about Hadoop. Hadoop is not there for first 3 points. For the last 2 points, about understanding Hadoop capabilities. That essentially means understanding Hadoop. And then capabilities. While we'll be talking about Hadoop capabilities, I have prepared a kind of a small case study that would be useful. That would be the first interaction point within this class itself. So that, just look out for that. And then we'll be gaining a bit more insights about Hadoop ecosystem, a quick comparison with the latest version of Hadoop versus Hadoop 1.x. So that's going to be the session objective. I don't think there should be any question up to this part, or if there are, I'm quite happy to answer them right now. Let me just proceed forward if there are no questions. Great. Thank you. Thank you for confirming. So no questions till now. So guys, the first thing first. Let's start with the basic itself. So what exactly is big data? Now, let me just go back. I want to understand from you people. You are here, definitely. You must have attended some of the webinars, or you must, like people like Raja and others are already working also in this domain. So what is your understanding of big data? Just a one-liner. Could you type? By the way, this typing thing is very important. You are not in a face-to-face class, so it becomes very easy for us to divert. So I typically force people. Anybody? Guys, quickly, if you could just respond to my okay. Varun says this. Okay. Only Varun has replied till now. Probably, so Varun, just a second, sorry. I just had some problem there. Okay. Raja said, big data is a problem, Hadoop is a solution to solve big data problems. Nice way of putting, though I would like to enrich it. Varun, your attempt is also good, but it is, I would say, it needs a bit more articulation. He said, as the name points, huge volume of data. I only understand big data means big amount of data. That is from Shubhram. Okay, fine guys. Fair enough. None of your understandings are wrong. But now so this is your baseline, right? Typically we developers talk in the terms of baselines, right? So this is going to be your baseline. Let us conclude this discussion and let us see whether your understanding is enriched after this or not. Right? Make sense? Make sense, right? Raja, Shubhram, Varun, others, right? So let us get started with it. Okay, now I'm going back to the slide which I purposefully, had hidden earlier. Okay, so as the first thing is, right, Shubhram, no prizes to guess that. Big data, you're talking about huge volume of data. Okay, now how do you define huge, by the way? What is the definition of huge? Okay, so some years back, especially people who are with SQL background and all, so you must have heard from your DBAs, right, that if your database file size is, let's say, around 5 GB or something, they would warn you that, see, you are working with a very big data instance, or very huge, your database is quite big, database size is quite big. That was the definition some years back. Now, today, that definition has moved, so the scale has moved from early GBs to the late GBs. What I mean to say is, some 4 or 5 GB of database file to now we are talking about late GBs, means 500 GB data, 800 GB data, 1.5 terabyte data, 6 terabyte data, right? So early terabytes. Petabytes, I'm not really sure whether it applies to the companies which are mid-scale, but yes, companies at the scale of eBay, companies at the scale of LinkedIn, Google, Facebook, right? They are definitely in the scale of petabytes or even in exabytes as well. Exabytes, though, it is like combining all of the data, right? So this is how what I'm just trying to say is, yes, though big data means huge amount of data or huge volume of data, good, but the scale itself is moving. Okay, so probably if there would be another session, probably some years down the line, people would be talking about late terabytes, right, and early petabyte kind of thing. I hope everybody is getting my point, right? So huge volume of data, good, but that scale itself, it's a moving target, which is continuously moving forward. Okay, so now what is so big deal about this huge volume of data, right? So guys, let me just give a formal definition to this big data thing, and then let's get started. So big data is a term which is basically used for a huge data set, which is of the terabyte level and all, but the data set is quite large and complex. Okay, now due to this, what are the problems? The typical problems occur wherein you cannot use your traditional data processing applications to process this amount of data. Okay, so what do you really mean, and what exactly are the kind of challenges? Because this is a very crude term. When I say there are some challenges, that's fine. Let's define those challenges. Guys, when you talk about such a huge amount of data, complexity part I will come a bit later. Let's just sheerly talk about this huge amount of data, the storage part of this data. How are you going to store this amount of data? Are you going to store this amount of data on a single machine? Probably yes. Probably yes, if you are having, let's say, only 100 GB of data, 200 GB of data. Even your laptops support around 500 GB or 1 terabyte or 2 terabyte kind of storage today. Those kind of laptops are available. But if you are having more amount of data, can you put it in a single machine? The answer is straightforward, no. Okay, so what will you do? You will distribute your data. You will distribute the storage of the data, right? Some of the data would go in machine 1, some of the data would go in machine 2, and so on and so forth, right? What is it? You are talking about the distributed storage. Good. So the first thing is your storage is not conventional. Your storage is distributed. Very good. So the moment you talked about it, storage part of it, the sharing of the data, how are you going to distribute your data and other stuff, that is going to, so those challenges have already come, right? Now you have to distribute your data. Can you randomly distribute your data, or are you going to follow some sort of mechanism, some sort of indexing in the terms of the data which you are going to store in different machines? So you are talking about the sharing sort of challenges, right? The other part is, now that so I'm just talking at the challenges level. I'm not yet coming at the solution level of it, right? So you have somehow you have stored your data across different machines. Talk about the processing part of this data. Now you have to process the data, right? So how do you typically process your data? You typically run a program on a machine, and then you provide the data to the program, and then you clearly generate your output, right? So the flow is input, program, output, right? That's the normal flow. Now, your data is in different machines. So how are you going to run your program? Is the conventional approach of whatever way you used to write the programs gonna work? I don't think so. So there is definitely going to be a different paradigm for processing itself. Typically, if we are talking about a distributed storage, we are talking now about the distributed processing of the data. Guys, I hope it is making sense to all of you, right? I'm starting from the term, now I'm moving towards the challenges, and then I'll articulate more about them, right? So you had a huge volume of data, how exactly it is going to create problems, or how exactly it is going to be different from the traditional ways. The first thing which you saw at the storage level, the second thing which you saw is at the processing level. Now, distributed processing. Okay, good. You are processing your data in a distributed fashion. Now, that's where the contentions come. That's where the can of worms is open. Okay, what exactly are those challenges? Let's focus a bit more about them. So guys, the first thing, since you are processing your data in different machines, first thing, how do you ensure that, let's say your program is running on 10 machines, if the processing fails on machine 1 and machine 2, but not on remaining 8 machines, what should you do with your program? Should you abort it? Or should you restart it? Or should you accept the partial results? It's okay if you do not get the result of two machines. What if the machine itself is gone? Right? What would happen to the data which you stored on that machine? I hope all of you are getting this point, right? So what I'm trying to say is these are the challenges, right? If I ask you to write a program to handle all of these things, it's not going to be easy, right? That is one. Then, so this is just from the processing part. I have not yet touched, I have not even scratched the surface of the problem. I will be doing it in the coming slides. Okay, so that is first part. Then somehow you wrote a program, somehow you wrote a wrapper, somehow you are able to create or you are able to distribute your data, you are able to process your data also in a distributed fashion. Fine. Talk about especially those people who are in the ETL background can easily understand visualization part of it, right? How do you analyze this huge amount of data, right? That is one. Then the second part is visualization. How are you going to perform the visualization of such huge amount of data? So, okay, let me explain a bit more. Okay, so for example, you just want to draw a plot, right? A simple plot. Python guys and anybody who has done any programming in R is a statistical language. Okay, they can easily understand that they typically draw the plots, right? Or the bar charts or pie charts or histograms, right? Bar graphs, histograms, etc., etc. They are typically created from the data points, right? What exactly is the volume of data? That many number of data points you will be having. Good. Now, creating a plot with 200 points is okay. Creating a program with, let's say, some 2000 data points is still okay. But creating the very same visualization with 200 million observations, is this the right way? Can you visualize your data? Or even if you have put it, let's say, in a form of a plot, if you give it to your boss or let's say any business person, will they be able to analyze it? Just think. Just think. No. Simply no. Right? Because it will be just plain white noise for them. Right? So your visualization techniques are also going to change. Typically ETL guys, they typically prepare something called cubes. Right? Probably that approach to prepare the cube itself is going to change. Right? So I'm hoping that I'm just striking some codes. I'm just trying to make it relevant to the different guys who are working in different domains altogether. So be it the visualization part, be it if you are the processing expert, be it the processing part, or be it from the storage part itself, right? So how do you, I hope these are some of the challenges. I have just started on it. I will go in depth in the coming slides now. So I'm moving to the next slide. But before I move to the next slide, there is a question from Sohil. By the way, this is the right time. You can actually ask your question if based on the last slide, if you have any. Okay, so Sohil has a question. Sohil says, hi sir, I just want to know, I am not from programming background. Okay, Sohil, so do you want to say something more? What I understand is you are not from programming background. Is this your question, that I'm not from programming background, how can I work from in big data world? Is this your question? Sohil, if you are hearing me. By the way, others, if you are okay, if everything looks good, probably you can just give a smiley, or probably you can just say that yes, it's all good, we can move ahead. And I'm just trying to understand from Sohil. Thanks Aditya for confirming. Okay, so Sohil, probably if your question is about what I'm understanding, let me answer. You just missed the initial part of it. Okay, you just missed the initial part wherein I talked about my voice is not going. Yes, so Sohil, you are on mute right now. You are on mute. I'll unmute you. Wait. This is going to be nice. Just a second. Hold on. Sohail, hi. Good morning. You are on the air.
Hello.
Hi, Sohail.
Yeah.
Hi, Sohail. Good morning.
Sir, my question is there any prerequisite of learning big data in Hadoop? I'm not from programming background. I do not know any language like Java or C or PHP or any language.
Okay. See, the simple thing is that do you know SQL part of it?
No.
Okay. So how many? So sorry.
Even I do not know HTML.
Okay. What is the year of experience which you are carrying along with you? What exactly is the background with which you are coming? That would be.
Sir, I'm from digital marketing. I know search engine optimization, Facebook marketing, and somewhat social media marketing.
Okay.
But I do not know anything about the programming. Anything means not even HTML or any language.
That's fine. That's fine. So I'll just be very, very clear about the background and the kind of thing. So if you're from the digital media marketing and all, probably and not even knowing SQL, or probably the kind of line with which you are coming, it doesn't even go towards the programming side later on as well, right? Yeah. So probably those developer sessions and these things might not be the right thing for you right now, because you are completely from a different domain, right? But yes, having the knowledge. So there are some other courses wherein we typically talk about big data and its those kind of webinars and other stuff which we typically do for big data and its applications in different domains and all. They are going to be quite useful even for let's say the kind of work which you typically do. But for this course, the prerequisite is at least you should be carrying some sort of programming experience, either in Java or in, let's say, any other programming language. Programming language doesn't really matter, or in SQL or something else, and a bit of some basic concepts. What exactly a database is, what exactly, let's say, a programming language is, or distributed computing. So I'm not expecting anybody to be the guru of this area, but I'm definitely expecting, if I talk about distributed computing, it should not be an alien word for anybody. That's the kind of thing. So the prerequisite here is, for the programmers to know Java, but if those, like, there are people who are, so there are some complementary Java classes which we give to people, but since you are from a different domain, probably Hadoop admin might be the better option, if at all you tend to, make your career in this area. Okay, but definitely not programming, because programming is a different world altogether. Sohail, I hope I answered your question.
Yeah.
Okay.
So I mean, this session may not.
Sorry.
So sir, this session will not help me, right? I mean, I need some.
See, this session
knowledge.
Definitely. At least this session is going to be useful in the terms of what you'll understand what exactly big data and other stuff is. So I would go rather opposite. I would say this is the session which will definitely help you. But after that, it is going, when we are going into the details of programming and other stuff, if you really want to go towards the programming part of it, you have to put a lot of effort in the terms of understanding at least some sort of programming, and then coming back with it. Otherwise I would be very honest. It would be a very steep learning curve for you. It would be very difficult at that point of time.
Okay.
Okay. So
yeah,
do I answer your question? Okay.
Yeah, fine.
Thank you. Yeah. Okay, guys. So I hope others also listen to our conversation, and this is what I typically mean, wherein I typically unmute any person and then I try to answer the questions then and there. It is typically faster. Okay. So now let me just get started with the further part of, okay, the first thing. Now again the questions back to all of you people, right? Where do you think the term big data has come from? This is interesting. I have not put it in any slide. I have never ever discussed in any of the webinars also. What is your opinion? Shubham, Atul, Varun, Aditya, everybody, or everybody, right? You are coming because you must have done a bit of googling about it, right? So here is this thing, big data. Where did it generate? I'm sure by the time you people type your responses, I'm sure some of you might be thinking Facebook kind of scenario, social media marketing sort of scenarios, or e-retailer kind of scenarios and all, wherein these are the typical sources, or these are the usual suspects of big data sources generation, or the term must have been coined here. Guys, let me tell, this term was never ever coined by the IT field at all. Okay, this term first got started in the area of basically astronomy part of it. Okay, in the in early, or I would say late 1990s, wherein you started getting a lot of satellite pictures and other stuff. Okay, so scientists had to kind of analyze this huge amount of data, or even the area of genomics and other stuff, right? So Varun was happy about it, Atul, others, right? So I'm not really asking about the examples. I'm talking about the origination of this term itself. I hope it is just adding some sort of knowledge to all of you. Okay, so this thing got started in early 1990s, and the field was completely unrelated. Area of genomics, area of basically those satellite image processing and other stuff. Now let us get into some of the some of the basic part, okay, about the sources of big data generation and things like that. Okay, so New York Stock Exchange, this is a nice figure which you are seeing some sort of thing. Let me just give you some more examples apart from this New York Stock Exchange, which you can easily read it, right? So New York Stock Exchange typically generates around 1 terabyte of data, okay? 1 terabyte of data, which is the trade data per day, okay? So 1 terabyte is, so just focus on some of the finer points. 1 terabyte is a huge volume. The second thing is, this is being generated in a day. And what should happen? All of this data should be processed to find out the optimal trades before the next day processing starts. So I hope you are understanding the gravity of the problem. You captured, first of all, this huge amount of data in the entire day's business. Then you have to process this data before the next day business starts. Okay, in the off hours, you have to process this data so that the next optimal trades are automatically decided, right? So we are talking about volume. Is this something new? No, we have already talked about it. We are talking about the processing part of it. Is this something new? No, but look at the time window. Look at the time which is expected, right? 1 terabyte of data within, let's say, a night, right? Because early morning next day, you will be starting your business, right? So these are some of the things, right? I'll talk more about those things. I'm just giving you some heads up there. The other example, how many of you have heard about LSST project? LSST project, Large Synoptic Some Array of Telescope. Real-time processing to is Hadoop capable of it? Aditya, you will get an answer automatically in some more slides. Okay, Aditya, very soon you will get the answer of it. Okay, but my next question was very simple. Have you heard about LSST? LSST is a project. It is basically the astronomy related project, wherein it's an array of telescopes which is used to get the images of our galaxy. Okay, now why am I talking about it? So guys, this project got operationalized in 2001, year 2001. We are in year 2015. Okay, now from 2001 to 2010, this project created almost around 150 terabytes of data, 150. Okay, that had to be processed, and 150 terabytes is a big number. I don't really need to tell you about it. So what is the new thing? Why am I, talking about this volume thing again and again? Am I repeating myself? No. Let me talk. So the story does not end here. It starts from here. Its successor is going to be operationalized in 2016 early. We are in 2015 start, right? 1 year down the line. Now, let's talk about it. So that successor is kind of much more powerful telescope and other stuff which will be replacing it. Now that project is going to capture 150 terabytes of data per week. Per week. Are you just take a step back, okay, and just focus on that statement once more. We are talking about 145 terabytes, 150 terabytes of data in 10 years. Huge number. Now we are in 2015 and just 1 year down the line we are talking about 150 terabytes of data every week. 10 years, and now it is all of the data is being captured within a week, right? Isn't it a huge, tremendous increase in the rate of capturing the data? Guys, Varun, I'll answer your question as well. I'm batching your and Aditya's question, but right now I just want all of you guys to focus on this part. Isn't it we are talking about a huge volume and the rate at which we are calculating the data, right? So can we call it as that speed of the data? Can we call it the speed at which we are collecting the data, right? Or the velocity at which we are collecting the data? More on that I will explain in a short time. Okay. The other example somebody has already given, I think Aditya or probably somebody else, who said airplane logs. Atul had answered kind of airplane logs. Now these are very important. So a typical jet flight, right? A typical jet flight of 30 minutes, okay, basically is capable of collecting almost 1 terabyte of data, flight sensor data. There are various sensors, right? 1 terabyte data for 30 minutes flight. Now just think about a flight which is connecting two ends of Atlantic. And now think about a flight, think about all of the flights originating from all where in the world in a given day. Aren't we talking about, isn't it mind-boggling? So volume was one part, but the rate at which you are gathering this volume, isn't it kind of alarming and mind-boggling? Is there any system in the world which you can think about which can process this huge amount of data, even in the big data world also? So there are some challenges there as well, right? But again, I hope I'm not trying to prove anything at this point. I'm just trying to give you the perspective before you get into the things. Why exactly, or what exactly makes big data world so challenging? What exactly makes it one of the hottest areas of discussion, or probably the jobs and other stuff? This is one of them, right? So I'm just moving to the next slide without concluding anything and without answering Varun and Aditya's question. I will answer them very shortly. Okay, let us focus on this slide for a minute. Okay, for some seconds I would say, and just see what is it. Okay, we are talking about the exponential increment of the data. Now whatever examples I gave you, 150 terabytes of data within a week, 1 terabyte of flight sensor data within 30 minutes of flight, all of them are indicating this. Is there something new which you are seeing in this slide apart from the huge volume of the data and the velocity at which you are collecting the data? So these are the two things which we have already talked about. There is a third aspect here. If you look at this exponential growth of the data, you can see there are two curves which are going on. One is this blue color part, and the other one is this green color part, right? So guys, that's the part. See this blue one. So that area which is covered under blue is signifies the rate of increment of the relational data. Okay, it signifies the rate of increment of the relational data. Just a second, guys, are you all able to hear me? Aditya is not able to hear me, so I just want to check it with all. Okay, thank you for confirming. So Aditya and others as well, sometimes what happens is there are some of the internet issues at your end, might be some bandwidth related problems or something. So if you face it for a long time, sort of, we typically suggest to log out and log in. That really helps. This is just a tip. I'm sharing it from my previous experiences. Okay, now coming back to the point. So my point of this slide is not the volume and the velocity. My point at this slide is, if you look at the growth which is driven by the relational data, it is still big but manageable, almost linear. But look at this guy which is going, exponential way. That is a guy which is, this data is typically called, that if you see that green color data is called the application data. Okay, what do you really mean by this application data? And by the way, the blue data is called business transaction data. Okay, so what is the difference between these two? I hope seniors any would be knowing it, but there's those guys who are starting their career. So business transaction data is the data which is typically the structured one. So for example, somebody does a bank transaction, right? Somebody does a bank transaction. At the back end, you are having a table for the transaction, for the account, for the logs, etc. Everywhere you are having some sort of a structure, right? For the transaction table, you might be having certain columns, right? What is the account number? What is the customer ID? From where did the transaction happen? What was the amount of the transaction? Whether it was a credit, whether it was a debit, and things like that, right? Who authorized it and things like that, right? So that is the typical structure of the data, and this is called the business transaction. I hope it should be making some sense. Now, talking about the application data. Application data typically means the user generated data, or the machine generated data. So like some time back, one example was given for aeroplane logs, right? Atul gave that answer. That is a application data. Some application is generating it, or there were some people who are from telecom domain. I hope you can easily understand. There is a lot of data which is generated at all of the servers, or all of the probes, or all of the BTS, base transceiver stations, basically, right? At all of those locations. Sometimes people ignore it, calling it as noise. But yes, that is the application data which is generated. Your web server logs, your machine server logs. Now, this is about one kind of data. But then there is another type of data, like your Facebook post, right? You must have updated something on Facebook. Now, any video which you have uploaded, any picture which you have uploaded, you have connected with somebody on LinkedIn. All of this data is the application data or the user generated data. And then the companies like YouTube, basically Google, Facebook, LinkedIn, eBay, and to name others, they basically thrive on the data generated by you, not by them. Okay, so what is so different? Talk about the business transaction data. You had certain fields, certain data. Talk about your Facebook post. You could write a simple text. You could upload an audio file. You could upload a video file. You could upload an image. You could do whatever, right? So that data is definitely not going to follow any structure. That data is not going to have any column. Your comments are not going to have any column, right? They are just a free formatted text. Your picture is not going to be a column as such, right? It's just a unstructured data, right? So the point is that the growth, the volume and the velocity, whatever we talked about, is not due to the structured data. It's not due to the structured data. Probably the structured data might be contributing it in the terms of historical analysis. This is what most of the companies are trying to do now, right? Companies like Sears, Citi, Wipro, and all of those, they are nothing but just the vendors anyway, right, to the bigger companies. So you might be doing some sort of historical analysis of the data, okay, but when it comes to the real big data processing of this complex, the user generated data and all, you're talking about the complex and unstructured data, or probably the semi-structured data. Does that make things clearer? Was it clearer to you now? So if it is clear, then that's where this is a slide where I would like to conclude some of the things, and then I will be open to some of your questions. Okay, so these three characteristics, we talked about a huge amount of volume of data. That is the volume characteristic. We talked about the rate at which you are collecting the data. We are talking about the velocity part of it. We talked about the kind of data. Could be your Facebook post, could be your image, could be your video, anything. We talked about the variety of the data. They are typically called the 3 V's of big data. Okay, and this is the standard definition. You can see this definition on the website. This is not Skillspeed definition. This is our own, basically the standard definition. Sometimes people add the 4th V also in it. This is called veracity. Okay, it is not mentioned because it's not there in the official definition. But yes, there is a 4th V as well called the veracity. Veracity typically means that the imperfectness of your data. So for example, what I'm trying to say is, let's say LinkedIn is my favorite example, guys. So LinkedIn, everybody must be having their profile. Now there might be some of the students who might be having some of the educational experience to show, but no professional experience. Similarly, professional experience guys and all, not everybody would be having some sort of honors and rewards section for them, right? So these are called the imperfectness of the data. You might be having some of the data, or the other sort of imperfectness is, let's say you are having the data of names of people. I'm just saying names, guys, your name, my name, everybody's, right? That itself has the imperfectness. How? The imperfect thing is not in your name, it is in the distribution of the data. Okay, so I hope others are understanding the point. The point is, there are a lot of names which start with A. There are a lot of names in this batch itself, you can see, right? There are a lot of names which are starting with V or S or whatever, right? But there are very few names which start with X. I don't know any name which starts with X. There are very less names which start with Z, right? Or T for that matter. So this is another imperfectness of your data, means your data is skewed, right? Some, if let's say you are making those alphabets, right, as your keys, then you are having a lot of data for A, you are having a lot of data for B, C, but very less data for Z. So if you distribute it in different machines, then you are not going to do the load balancing properly. I hope others are understanding the points, right? That is typically called the veracity part, whereas it is yet to be included in the formal definition of it, right? Guys, now is the point. So when I started this discussion, I asked for a baseline from you people, right? Your baseline understanding. Now, this is where we completed one part of the discussion. Your understanding, did it improve in the terms of the examples and in the terms of the kind of challenges which are practically there, right? I didn't talk about, I could have started this session with 3 V's of big data and explaining them. No, I took a different approach wherein I first told you the challenge, and that's how the definition is derived. Definitions always are derived from the circumstances. I hope it is making sense. Can I get a feedback of the class right now? And then I'll try to answer some of the questions. Okay, great. Thank you. for confirming. So Varun had a question wherein he said even the disaster management will be big risk because with this much volume, right? Varun, you are 100% right. So we will see that yes, this is another aspect, and how does Hadoop take care of this part? Okay. Can you give me some more examples of semi-structured data? Very good. So Raja, what I would say is just hold on. There is a proper, this is a question itself with some examples. Okay. So there would be a question to entire class very soon on the very same question whatever you have asked. Okay. So just hold on for some more minutes, Raja. Okay. You will automatically get the answer. And Aditya, your question, right? You asked about some real-time processing, Hadoop capability and other stuff, right? I'm still not answering. Okay. Okay, so please don't worry because we are moving in that very same discussion. Okay, just be more patient. Okay, now let me just move. So big data in industry. I typically don't spend much time on the slide. Okay, the reason is very simple. All of you who are attending this session, right, must be coming from different companies and you must be having different projects. Okay, or probably you are expecting to get into some projects or big data world altogether, right? So they themselves are the example of big data in industry, isn't it? Let us apply a very simple common sense, right? That way. Now, that is, having said that, that was a very crude definition. Let me just give you some more examples which are written here. That's fine. They are kind of known, discussed, but I'll give you some interesting examples also. Okay. So the first thing is when it comes to the e-retailing world or e-tailing world and all, the typical use cases are the recommendation engines. The typical use cases are the targeted ads or your search quality improvement altogether, right? They are the typical ones which are the typical use cases of big data in the retail industry. Though right now I'm talking about big data, it doesn't essentially mean for Hadoop. Big data is a big word. You will see it very soon after this slide. Okay, so the first thing is recommendation engine, right? You bought something, you might also like this, right? They are the typical recommendations which are generated. So of course they process a huge amount of data, then they apply some sort of machine learning wherein they say, user-based recommendation or item-based recommendation depending upon whatever your browsing history is, and then they produce different results. Okay, so anyway, that's the area of machine learning and Mahout and other stuff. In the telecom area, it's one of the wonderful areas, your call detail record analysis, your customer churn prevention through many various ways. So I was the part of one of this very interesting project in telecom domain. It's a company which provides the roaming services, value-added solutions, especially those people who are in telecom domain can easily correlate to it. Okay, so there was a kind of analysis which we had to do for the silent roamers. So what is the definition of a silent roamer? A definition of silent roamer is, let's say, and when we talk about roaming means international roaming. I'm not talking about the national roaming part of it. So you have stepped out of India, you have gone, let's say, to UK, okay, and if you switch on your mobile, but you are not using it, right? It is just on, and you are not making any calls, you are not texting anybody, you are a silent roamer. Or probably some sort of thresholds that 2 days you have spent and you have talked for less than 2 minutes, right? And you have not done any message. So any such criteria, right? They are typically called the silent roamers. They are using the services, they are connected, but they are definitely not using the services. They are typically called the silent roamers. And your bandwidth and those resources are very precious for any of the telecom operators. So telecom operators would definitely like to know such kind of people versus the people who are highly using the services in a high fashion, so they can create the campaigns accordingly. They can create some sort of packages for those people who are the silent roamers to make them mid-use or low uses customers at least, Okay, so they are the typical kind of campaigns, and companies would like to know them real fast. Real fast means, let's say within a day, they would like to know who were the silent rumors and all, right? By the way, just believe me or not, but within India itself, this is a business of almost some 50 crore rupees a day. 50 crore rupees a day. I'm just giving you some statistics about it, and at international level, it is even more. Okay, so but again, this is just an idea. And by the way, this 50 crore rupees a day for a single operator. I'm not talking about all of the operators. Okay, so just as some of the perspectives of my experiences of some projects. Then talk about healthcare and life sciences. Nice, there are a lot of projects. I think this is not really the right time when we can talk about all of them. Okay, government, again, Aadhaar project and other stuff. Those are some of the things which you already know that yes, these are the known implementation of Big Data World. I'm very tempted. Let me just see. What is the time right now? It's 8:21. That's fine. And yep, we will go to the batch processing and real time processing part of it. Okay, so the time is there. Guys, apart from this, there are some of the very unknown, or I would say some sort of dark applications of Big Data World as well. Okay, luckily or unluckily, I had to be the part of one of them. That project is still in kind of work in progress. So I'll tell you, it is very interesting. Probably, I don't know whether you would ever get to work in that. So there are various HR companies, there are various consultancies, and then what is the typical, I would say, concern for a company in terms of employees, right? Now I'm sure many of you would be interested. Okay, so you join a company, right? Then you have an employee life cycle, and then typically people leave the companies. That's typically that normal attrition rate and all. So especially when it comes to the product-based companies and all, they typically aim to reduce their attrition as less as possible. The simple reason being, the more time a person spends in a company, the more product knowledge they gain, and then they become even more valuable. Them leaving the company hurts the company the most. It hurts the company the most, right? Because again, they have to start their investment process from zero. In service company also it happens, but again, the impact is much lesser as compared to the product companies, right? Now, there are companies, what if you could just predict the kind of shelf life of an employee, the kind of early indicators wherein a person might be in the process of leaving the company, has not started, but kind of in the radar. HR team and your that talent acquisition and retention teams would definitely be interested, or depending upon the company policy, company might take a different action as well. Isn't it scary? So there is a project wherein typically what do they do is they get a lot of data, of course by the acceptance of the employees and other stuff, from various channels about the people, and based on that they predict the shelf life of an employee. And then there are various models which are applied on the top of it, and then kind of so if a person has put down the paper, then it is very difficult to retain that people, because the simple thing is they have put down the papers because of some reason. Okay, using these projects and using these kind of techniques, the companies typically aim to get these kind of occurrences even before they happen. Okay, for that they get the data about people from various social social media kind of websites, and then they process it. Interesting? Looks interesting? And you would be surprised, due to the customer confidentiality thing, I cannot really tell you the name of the customers who have signed up for that project, but they are very big companies in India. That's all. Guys, I hope it is making some sort of sense. Again, this was just a perspective. There are various others, but yes, I have been the part of that project, so I know about that. Okay, now let me just continue forward. Okay, so Aditya, you asked a question some time back, right? Now is the time when I'm going to answer that kind of question. Okay, so you will automatically get the question. So guys, when we talked about the big data processing and things like that, we said that I told you at the very start that you know what exactly big data is, and then the next part is about the kind of different processings which you can typically do. Depending upon the amount of data which you have, and depending upon the kind of analytics or processing which you have to do on that data, you might choose either the batch processing approach or the real-time approach. Okay, so let's first talk about the batch processing, and then we will talk about the big data batch processing and other stuff. Okay, so batch processing is the preferred way of processing the high volumes of data. Okay, and what really happens there, so over a given considerable period of time, whatever business agrees, it might be several hours or a day or a week or a month or whatever, even year as well, right? So the data or a lot of transaction, it might be some transactions data or some sort of facts data or whatever data it is, right? It is collected over a period of time, and then all of the data is processed together. That is called the batch of the data. Okay, that is called the batch of the data. So the data which is processed together is called the batch, and the time in which it is completed, it is called the batch window. Okay, so you are basically going to collect the data for a time, and then you are going to process it. When you do it at a very large level, so typically in the retail industry, typically in some other area, right, you collect the data for that entire year, or New York Stock Exchange example, wherein you are getting the the trade data for almost 1 year, and then 1 day, and then you are processing it together. They are the examples of batch data processing. Okay, when you are talking about such a huge scale, then you talk about big data batch processing. Okay, means you are still doing a batch processing but in a distributed fashion. Okay, so now we are structurally moving towards those parts, right? So now this third point, wherein Hadoop is focused on batch data processing. Hadoop is the specialized solution to do the batch processing of the big data, right? It is not focused on the real-time processing of the data. Okay, there is some sort of real-time processing capability which is available with Hadoop, but it comes from a different angle. Okay, with some limitation or some sort of I would say boundary conditions altogether. We will talk about that when we will be talking about HBase. Okay, but very simple. Batch processing typically requires the basically the separate programs for input of the data, process of the data, as well as sometimes for the output as well. Okay, so the typical examples are, let's say, your financial reporting or forecasting or planning kind of reports. Sometimes dynamic pricing, I would say dynamic pricing is an example which can go to the batch processing, to the near batch processing or near real-time kind of processing example. I'll go in that direction later. But is the batch processing understanding clear to everybody? Is the batch processing understanding clear to everybody? What exactly the batch processing is, especially for the people who are starting new? Aditya, did you get the answer of your question? So you asked a question about the real time. I gave you the answer about the Hadoop capability as of now with some support to the real time processing. We will see more about it. We will see more about it. Your question is still half answered. Okay. Now, let me just proceed further with bit more details. So traditional systems. So typically, what exactly are your typical approaches? If you are talking about the traditional way, then your database, your typical RDBMS systems and other stuff are the best examples when you store your data in those databases, and then you typically write your PL/SQL procedures or packages or functions or something, right, to do that processing, and even a given batch window. So that's the RDBMS kind of a solution, or the traditional solution, right, which we typically see. In the big data systems, typically Hadoop is the answer for it. Wherein, so by the way, we will be covering that part in bit more detail in few more slides, but Hadoop is a storage plus processing layer. So the difference is, for example, in Oracle world, the database itself, you can just store the data, right? You can just store the data. For processing, you have to use PL/SQL in another part, but your processing typically happens on the other grid, okay, not on the very same grid. But here, when it comes to the Hadoop world, you will be having storage plus processing layer together. You will see the differences very soon, okay? So be it the Oracle type of approach, or MySQL or any other approach, or be it Hadoop kind of approach, they are typically batch oriented, wherein you are you are either having no indexing capabilities or very limited kind of indexing capabilities, and typically if you want to do any real time or near real time kind of scenarios, right, the rates got changed immediately, change my prediction in real time or intraday batch processing sort of thing, then it becomes typically difficult in any of these scenarios. So be it Oracle, be it Hadoop. But the point is, Hadoop is definitely going to try, or Hadoop's specialization area is big data batch analytics, big data batch processing. I hope this is for the first time when I have talked about Hadoop, right? I have not yet talked about what is it. We'll come to that. Now, let's not spend that much time on it. This slide. It's all about that you might be having different sources of data within your organization: operational data, business intelligence, social data, etc., etc. You might be storing it in one place, then your typical ETL process of extraction, transformation, and loading goes there, and then you typically perform any sort of big data analytics on the top of it. Okay, so this is typically the batch processing. Now, let's come to real-time processing. This is going to be important. Okay, so Aditya has a question: how is Hadoop better than Oracle? Just like your last question, Aditya, this you are actually thinking logically. So again, I'm also explaining it logically, means I'm going to talk about it in a few more slides. There is actually a comparison. Okay, Aditya? Now, let me just continue there. So, when it comes to the real-time processing of the data and things like that, so real-time, now, let me first tell you, real-time processing in the traditional world, I'm not going to talk about that, but and this is for the first and the last time in the entire course, we are going to talk about the real-time processing and some of the scenarios. So I'll spend some time there before going for a break. Okay, so real-time processing, when you talk about the real world, you are typically talking about the OLTP systems, right? OLTP systems in the sense you withdrew some money from your ATM, right? Your account balances got updated and you got the advice and all that stuff. That was the real-time processing, isn't it? That's the example. That's the simplest example which I can say. But let's come to the big data world now, right? So that is a place wherein, let's say you were doing a transaction, let's say for Citibank, right? Citibank India, Citibank within India, Mumbai. So within Mumbai, Citibank Mumbai would not be having more than several thousand records, right? Or probably some lakhs of records, not more than that. So that's fine, it is still possible. But when you talk about, so guys, especially those senior people as well, I want your attention right now. The real-time processing meaning changes in big data world significantly. So first thing, there is no real-time processing in big data world. It is a myth, sort of. At best, it is the near real-time processing. Okay, and the typical real-time processing in the big data world typically means the continual input processing and outputting of the very same data. So it's not like you got some data, process it. No, you're continuously getting a stream of data. These are some of the words which you would like to remember. Okay, you are getting the continuous stream of the data. You are continuously typically processing your data, and then you are going to generate the output, basically the whatever is the process of the output. So output is also being generated continuously. Okay, so here the advantage of it is, since you are not collating your data, again this is applicable only in big data world, right? Since you are not collating your data over a period of window, right? Or probably your window is going to be very, very small, fraction of seconds. So the data which you have to process at one point of time is not big. It's very small, but the thing is you are continuously doing it and you are producing the output that way. So these are typically called the streaming kind of applications. Okay, and the typical examples are CEP platforms, right? Complex event processing platforms, or OIE, operational intelligence kind of applications are the typical examples of it. Okay, again I'm sure many people can easily understand that, or we can easily guess, complex event processing, operational intelligence seem to be jargon. Vishal is using jargon here. Let me explain a bit. So almost all of you must be having the debit cards with you, or the credit cards also, right? Don't worry, I'm not asking the details, but just that simple. So if somebody is holding, let's say, Citi credit card or something, right? Now I'll give you a simple scenario, okay? And then just focus on this part. So you are doing, let's say, a simple transaction, okay? You used your credit card, you are doing some sort of shopping, and you are doing it, let's say, from New Delhi, India, okay? And everything was fine. Your name, your expiry date of card, and whatever CVV number and all, your shopping went through successfully. Good. Now, what happens is, within 1 hour of this shopping, guys, this is very important for you to know, okay? Within 1 hour of this shopping, there is one more transaction which originated, which came to Citibank gateway, okay? And everything was again fine. Name, CVV number, expiry date, amount was within limit, everything. That in a typical scenario, this transaction would pass. Everybody would basically, you should not be having any problem. But when it came to the big data world, when your systems were capturing more data other than the bare essential, we decided to capture something called geolocation of the data. Okay, so the first thing told me the longitude, latitude, going for the Delhi thing. Within 1 hour, another transaction came, which is from Mumbai. Now, this raises some suspicion. Even though all of your details are same, your geographical location within 1 hour from Delhi to Mumbai, there is something suspicious, isn't it? So only after capturing this additional amount of information, this is the typical example of windowed operation. Within last 1 hour, since we saw, okay, there is similar kind of transaction from the similar thing, everything is same, but the geolocation is different, there is a chance that this can be a fraud transaction. Guys, I hope you are understanding this one. Since this happens, then the typical transaction does not go through the authorization process, it goes through something called referral. Then you typically must have got a call from a customer care asking that, sir, we can see there is so and so transaction happening from your card. Is this you who's doing it? Probably then you answer it. If it is legal transaction, then you can say, yes, probably my girlfriend or my wife or somebody else who is right now in Mumbai is doing this transaction, right? Right, guys? So that is the case wherein all of this has to happen in almost real time. It has to happen when somebody was doing the transaction on your credit card, isn't it? That is called the real-time processing in big data world. There is no point in pointing that the fraud has happened when it has happened. You have to point that fraud when it is about to happen or when it is happening. Guys, this example, does this make sense to all of you? Right? Regarding real-time processing in big data, right? Okay, Surajit, I'll come to that part. I think you joined a bit later probably. So Surajit, what I was just trying to say is this big data real-time processing is something which is kind of a myth, wherein you can have the near real-time processing. Okay, so the thing is, when you were doing the same transaction, we started capturing the additional data of geographic location. Okay, so the first transaction was perfectly legal, but it started from New Delhi. The second transaction was again legal, but it happened from Mumbai. If you look at the traditional data points, you would not see anything wrong with the data. But since in the windowed operation, we had set it like last 1 hour, so you saw these two geographical locations are, it is practically impossible for somebody to, travel nearly, within 1 hour from Delhi to Mumbai. So this transaction looks suspicious. That's where the real-time processing thing comes into picture, and it goes through CEP, complex event processing kind of platform. Okay, Surajit? Now, why did I give you the answer? Why did I give you this example? Because we implemented it. Okay, now the solution for this is not Hadoop. The other point. So this was not the point which I was trying to tell about myself, that we did it. No, the point is the kind of systems which are typically used for it are different than Hadoop. So you must have, I'm not really sure how many of you, but you must have heard about something called Spark, Apache Spark. Then there is something called Storm, okay, Apache Storm and all. So they are the systems typically which are defined to, or which are specifically designed to process the data in memory. Since you're talking about in memory, your data at one time cannot be more than a certain amount, and it has to be in a continual fashion. Guys, I would not really like to read the slide, but I hope this makes sense to you, right? And I'm not spending the time on this slide. Basically, this slide talks about that you're going to get the data from our systems, which will be having this hot data, the data in last some window, and then they keep processing the data. Okay, so I'm not really spending the time on this part. Before we go for a quick 5 minutes break, I'm sure many people would be wanting it. Are we all good up to this point? Are we all good up to this point? Any questions so far? Just a sec. Thank you. So there was a question from Raja. Raja, if you are hearing me. Yeah. Shubham, I will move. Okay. So this is the question, and that's why I hope you understand that I didn't answer. Yes, I will give. So this is a question, and answer is supposed to be typed in, you are supposed to type the answer in the questions tab. Okay, categorize the following to the corresponding data type. So what I'm trying to say is, you are having some JSON file. JSON means JavaScript object notation. Okay, it's a kind of a data type, like you have XML and other stuff. Okay, so it's a data format altogether. Then so typically, if you would have ever seen Twitter tweets and all, in the raw form, they are in the form of JSON. Okay, Word document, PDF file, text file, email body, whatever email you write, and the data from the enterprise systems and all, right? Database, CRM, etc. Which kind of data are they? So whether they are structured data, whether they are unstructured data, or whether they are semi-structured data. Your time starts now. Surajit, I hope you got the answer for JSON. So Aditya, rather than string, I'll just say give the answer in structured, unstructured, semi-structured. One shot. Raja? Others? Nice. So I got some answers in fractions. Let me not spend much time there. This is the solution in front of your screen. So JSON files are the semi-structured data. Okay? Semi-structured means they are colon separated, different data points, right? They are semi-structured. So there is a structure there, but you don't know what is the depth of those columns, right? So that's why it is semi-structured. Word documents, PDF files, text files, I don't need to explain. They are unstructured because you can write whatever you want to. And the same goes true for the email body as well. In an email, you can write whatever you want, or you can insert the picture or whatever, right? Any file and other stuff, right? And then data from enterprise systems, again, no prizes to guess that. It's the structured data because typically you would be extracting it from the tables and other stuff, right? So guys, I hope it is quite clear. Raja, did your question get answered? Right? So I hope others are understanding, right? When I don't answer the question, don't worry. There would be like, I would not leave the question at any point of time. Next question. This is interesting. So which of the following do you think are the big data solutions candidate? Okay. So all of the problems cannot be applied to big data, right? You have to analyze a file of 2000 records. Would you apply Hadoop analysis to it? No. So you can just say A, B, C, D, any of them. Adding the data to a predefined Excel template, kind of a structured data. Yes, Surojit. Yes. If you have defined the template, then yes. Raja says A comma B. Shubhram says A, B and D. Nice. I like your response, Shubhram. Aditya says A, B, C. Okay. So Aditya, C. Probably you would like to explain why C. Then Atul says A, B and D. Okay. So let me just give you the right answer. Wow. Why C? Right? Right. I'm sure Atul, Surojit, Shubhram, everybody, right, must be worrying. What do you mean? Like it is just one MB input file, right? Am I right? Shubhram, this is what you are thinking? Surojit, Atul, everybody, you are thinking that way? Now, just keep thinking. Okay. It's not kind of a joke. Just think. We are going for a break. It's 8:50. Let's meet at 8:55. Right? Does it work for everybody? We'll meet at 8:55 with the answer and then the further discussion. By the way, I would just like to take a kind of a feedback from all of you. How's the pace and everything which you are finding? Good, slow, fast, okay? Because I'm just taking both of the ends of the spectrum. There are very senior people as well as starting people as well. So I'm taking everybody into account. Okay, guys. So we will meet at 8:55 with the answer and the discussion.
So hi, I'm back. What about others? Could you please confirm on the communicated, basically this questions tab? Is everybody back? Sure. So Shubhram is back, Aditya is back. What about Varun, Surajit, Raja, others, Sandeep? Yep. Great. So Surajit, what is your background? Like from which, how many years of experience and which domain, technology, platform and other stuff from which you are coming? By the way, we did this kind of small thing at the start itself, so you just missed out that part. Okay, let me just get started. By the time, you know, others, you must need some time to type as well. So, yeah, we were just on the discussion of, you know, C can be handled, yes, on the third part, right, wherein interconnecting nearly 50,000 data points and then using typically 1 MB input file. Guys, interconnecting 50,000 data points, okay? So I'm giving you this example, and this is another classic example of big data world itself, that sometimes it is not just the volume which might be deciding to go for a big data solution. This is the big takeaway from this exercise. Interconnection of 50,000 data points. Let's say you have 1 MB input file, that's fine, but what are you trying to achieve? Let's say you are doing a self cross product of 50,000 records, okay, 50,000 records, self cross product. So overall, due to whatever reason, and I'll tell you there are enough reasons about it, okay, so you are saying you are talking about 50,000 into 50,000, you are talking about 10 raised to the power 8 plus records, right guys? You're talking about your output in the order of 10 raised to the power 8, okay? So that is the point, okay? Because interconnecting, what does interconnecting mean? You know, cross product, and there are enough reasons. There are several places, especially when you will go to the machine learning part and other stuff, you will be doing a lot of, you know, a lot of cross product related activities wherein you will be finding the similarities between items in a set, okay, with each other sort of. So typically they are the NP2 sort of operations, okay, or NC2 depending upon whatever kind of analysis you are doing. And then even though your input is not very big, your processing is going to explode the data. So your input data is small, but in the processing stage, you are going to explode the data up to the extent that the output becomes huge. Is that clear? Right? Guys who excluded C, basically. Aditya, make sense? I think Varun, others as well, right? Could you please confirm? Or if it is not clear, then I'll explain. Okay, that's great. So this is another important aspect, that it is not just the volume, right, which might force you to go in that direction. Okay, now Hadoop for batch processing. Just a second before I proceed. I will not talk about Hadoop for batch processing right now. Okay, Shubhram, I will explain. Just a second. Let me just continue to this. I will not explain Hadoop for batch processing right now. The reason is I will come back to this slide. I will come back to this slide in a bit while after, you know, I complete a nice, or I would say quite intensive discussion, okay, after few more minutes. Okay, now let me just quickly talk about, so Shubhram says, can you please explain once again? Sure. Shubhram, are you there on headset and mic? Basically, can I put you on there? Please, if it is possible. I typically prefer that way so that, you know, it gives me also the privilege to talk to you also. Okay, not a problem. So you can be on headset from next class onwards. You know, this really helps. This is for the first time, that's fine. Okay, so let me just explain, because if I would be talking to you, it would have made much more sense, much more faster. Simple thing. So you need to confirm by either saying okay or not okay, as in when I explain right now to you. So you have 50,000 data points, which is, let's say, 1 MB input file. So your input data size is not huge, but you want to do the interconnection. Interconnection means 50,000 data points, take record number 1, okay, and then connect it with all remaining 49,999 records. Right? Shubham, are you understanding this? Can you say okay or not okay? Just type this, either okay or not clear. Okay, so you took the first record, let's say, so what did you do? You just created a cross product, right? You take the first one, apply it with all remaining 49,999. Take the second record, again apply it with all remaining 49,999 records, and the same thing you do it. So how many combinations do you have? You have 50,000 into 50,000, right? Right? And that's what I'm saying. So if you just use your calculator, right, just get the output of this, right? It would be 2.5 multiplied by 10 raised to the power 8, 10 raised to the power 9 actually, right? So you are talking about 10 raised to the power 9 order, right? 2.5 multiplied by 10 raised to the power 9 would be the number of records. So even if your input size was only 50K, your output size is pretty huge, right? And that's where it becomes a big data solution candidate. You cannot really solve this problem using a traditional solution. Is that clear to you now? Shubham, make sense? Great. Thank you for confirming. Okay. Now let me just go to the, so I'm skipping this slide right now because I will come back with more data points to it. Then it will make much more sense. Okay. Well, let us look at this slide. So what to look in this slide? This looks complicated, isn't it? It certainly is complicated, to me at least. So let me just declutter it. So what am I trying to achieve? Let me just first tell you, and then this entire discussion will make sense, because you should be understanding what are we trying to do with it. Just a sec. Yeah. So guys, whatever you are seeing right now on your screen is loosely any BI architecture in your respective organizations. Now, when I'm talking about it, your actual, these building blocks, right? These building blocks might be different from company 1 to company 2. Some building blocks might be present, some of them might not be present. Sorry. But your layers would be there. Okay. So for example, typically, how does it work? You typically collect the data. You have a collection layer wherein you are collecting the data from different data sources, right? Then after collecting it, you typically go to store the data, right? So you have some sort of storage layer, right? Wherein you are going to store some data. And then you typically do some sort of ETL processing, right, on the data, which you would have captured from the different data sources altogether. And then you typically have another RDBMS, another storage, which is either sort of aggregated data, or you call it as process data, or you sometimes call it as cubes, or whatever you want to call it. So this is typically, this RDBMS typically represents your reporting database. This is typically your reporting database. On the top of reporting database, you have various BI solutions which are kind of created, right? It might be either business objects, it might be OBIE, or probably ClickView, or some Pentaho thing solution, or whatever, right? So you might be having various other solutions available on it, right? At the very high level, this is the logical scheme of the BI architecture of any organization. Am I right in saying so? Is our baseline correct? I am expecting the answers from like some senior people as well. So if you could just say that, or confirm up your understanding whether it makes some sense with all of you, right? So at the very high level, this is the logical structure. Now in your specific organizations or something, some of the components might be changing, that's fine, but your layers are not going to change, right? Now with this, if we are quite clear about this basic part, let us focus a bit more on how exactly this architecture is challenged by putting big data thing into picture. Okay, so what really happens then? Okay, let's start from zero. So the first thing is the collection part of the data. Okay, so you are going to collect the data, okay, and typically sorry, I have moved to the next slide, sorry. Okay, so you typically are going to collect the data from multiple data sources, and you are going to store it in the storage only grid. What do you mean by that? You are going to store it in any of the databases, right? Might be MySQL, might be Oracle, might be Postgres, or whatever, right? You're going to store it in some sort of table. Guys, the moment you talk about some sort of table, means some sort of structure, right? You are forcing the structure to this data. Means at the first point itself, this red cross, right? This red thing, you are limiting yourself from exploring the high fidelity raw data. Okay, what do you really mean by that? So very simple. I gave you the example of Citibank, right? Or basically any banking related data just before we went for the break, right? So typically in any of the transaction tables or something, you might be seeing the time of the transaction, the amount of the transaction, the nature of the transaction, the authorizer, the initiator, the several other things, right? The teller number where it started, the branch number where it started, and things like that. But was this the only data which got generated with that particular transaction? No, that was not the only data which got generated. There were other elements of the data like geolocation. What was the IP address of the machine from which the transaction got initiated, and things like that, right? That was the raw fidelity data. But since you had put a structure, you must have decided to ignore some of the data parts, to ignore some of the attributes. So if you are not capturing the raw fidelity data, if you are giving some sort of a structure, you are losing the fidelity of this data itself. Means you're losing the information at the collection time itself. Is this part clear to everybody? And I'm kind of, these are my checkpoints. These are my checkpoints with everybody, because it becomes very difficult now for me to come back after some time. Are we all on the same page up to this point? Great. Now I'm going to the second part, if this is quite clear. Okay. Now, so guys, you basically have put some sort of a structure, and then you have put the data into your storage only grid. Now what happens after that? So your raw data or your transaction data is typically there in all of the transaction tables. Then you are going to apply some sort of ETL process on the top of it, right? Extract the data, transform the data, and then load it basically to your reporting database. That's what you are going to do. Now, ETL compute grid. ETL is what? It's a kind of an computation which happens there, right? You are doing the ETL computation then and there itself, and that's where you head for your second drawback. Moving data to compute does not scale. So you are going to the compute grid. Basically, you are taking the data from storage only grid and then you are moving to the compute grid. There is a limitation, because then what are those limitations? Those limitations are based on the kind of machine or the kind of server you are using, right? How much data can you load, right? How much data can you process? How much data can you transform at one go? So probably you are limited to 2 GB data. Business comes back and says, no, I need more. So okay, your simple answer is, okay boss, give me more processing power, I will do it. They upgrade the machine. Okay, so from let's say 2 GB RAM, it goes to whatever, 64 GB. Tomorrow again something goes up, so you will again upgrade it. But there is a limitation in terms of money as well as technological this thing, that you're talking about the vertical scalability. Guys, vertical scalability. So this is the right time for me to talk about vertical scalability. You are saying vertical scalability means increase the strength of the same machine, go vertical up. Okay, so you had a machine with 1 terabyte storage and let's say 8 GB RAM, you need more processing power, make it 2 terabyte and 16 GB, make it 4 terabyte and 32 GB, and so on and so forth. This is called vertical scaling. I hope the concept of vertical scaling is clear, right? So the problem is your ETL part, right? Your ETL computation, right? Your ETL, just a second. Surajit, 1 TB of what? What do you mean by 1 TB? 1 TB data. Okay, 1 TB data. So you're talking about 1 terabyte of data and other stuff. So you're going into the vertical scaling part, which is both expensive, point one, right? I don't need to tell you that how much cost it would be. And at the same time, it has a limitation, because after a certain point of time, your performance improvement will not be linear. It will degrade. Okay, so that's your second point, right? And everybody understands it. The organizations are mature enough. Organizations do understand this part. So what is the solution? What is the solution? You typically go for your traditional systems, right? I'm talking about traditional systems. So guys, what do? You typically go and you will say, okay, I have this much data. I understand. I cannot do the ETL process for all of the data. Good. And I have limited money also. Okay. So what do? I will say, boss, I am not going to process this entire amount of data. I will process, let's say, last 2 years of data. And then remaining 8 years of data, whatever bank is supposed to do for due to some regulatory requirements or whatever, let's archive that. Right? Let's archive that. Okay? So you're talking about, I'm sure all of you, like not all, at least those people who are from BI domain, who are from those ETL kind of backgrounds, these concepts would not be new, right? You talk about archiving of the data, archive database, right? In banking and all, it is very important part, right? So you archive your data and then you just kind of put a window on your data and then you do the ETL processing only on the relevant data. So you define, somehow you come up with the solution wherein you say, okay, I will have to process in last 2 years of data and I'm not going to process last, remaining 8 years of data. So that way the ETL compute grid can survive. It can survive for some time. Okay, you have done some sort of thing. You are able to process it. But guys, isn't it the third problem? You are giving the premature death to your data. Also, the kind of patterns or the kind of things which you are seeing right now, right? Whatever, let's say your BI reports and other stuff, whatever trends and other stuff they would be reflecting, will they be true? Will they be the true one? No, definitely no, because they are based on a window of the data. They are not based on the entire data. So you have lost really the actual value of the data, which would have told you, let's say, some more exceptions which might have occurred in past. Right? I hope you guys are all understanding the importance of these things. Right? Yep, Surajit, I'll explain. I'll come to your questions as well. But I hope all of you are understanding the challenges with it. Are we all on the same page in the terms of challenges? Then I'll answer Surajit's question. He has asked 2 questions. Can you please explain in the first point briefly? Somehow I just missed it. No problem. So Aditya, so not only for Aditya, I think for everybody, I'll briefly repeat my 3 points. The first point was, since you are, while storing the data, you are applying a structure. You are saying, I will capture my data only in a specific structure. You are kind of, missing out on the raw data. Means some of the additional data which you are not capturing is anyway lost at the storage time. Is that clear, Aditya, now? So that's where you are saying you cannot really explore the, high fidelity raw data. Second problem was, if that much data, let's say if the data goes at real that, terabyte level and all, then your ETL computation grid starts facing the stress problems, right? And what are those stress problems in the terms of, you need more memory, more storage and every other stuff. And that's where you hit the wall, because you are going towards the path of vertical scalability. Business typically understands it. There is a limitation, practical limitation, money and everything which can be spent. So then the business typically comes back with the archival strategies. They typically say, we are going to archive that much amount of data and we will process only a specific window of this data, right? That's what is the solution typically. But then it means you are giving the premature death to your data, and your outputs are generated based on a subset of data, not the entire data set. And then the chances of whatever trends or whatever reports you are seeing might not be really correct one. Is that part clear? All those 3 challenges to everybody? Aditya, Shubham, everybody, right? Now, Surajit has the question. So with increase in memory size and scalability and performance is degrading following some functions, right? So Surajit, no. The point is, if you increase your, let's say, memory as well as storage part of it, you can improve your performance up to a certain extent. You are going to shell out huge amount of money for that, because you will be going for a huge, bigger and bigger servers. But that too, after a certain point of time, if you keep on increasing your RAM, if you keep on increasing your, let's say, storage on a single machine, it's not going to scale beyond a certain point linearly, right? After a certain point of time, the performance gain which you will get for an investment of money would not be that much on a single machine. Is that clear, Surajit? That is the answer of first question. Second question which we have asked, can you please briefly tell us about ETL? What exactly happens here? So simple, Surajit. ETL simply means extraction, transformation and loading. So simple thing, in the actual, let's say, scenario, you might be having the raw data wherein the branch location is 001. Okay, the amount is whatever, XYZ, right? And the official who performed this transaction is, let's say, V. Kumar. Okay, is that clear? That is your raw data. Now when you extract it, you would be doing a query. When you are transforming it, you would be saying 001 branch actually means Mumbai Andheri East branch, right? So instead of 001, you will be replacing it with Mumbai Andheri East. And then V whatever, right? Something V Kumar or something, that user ID would be replaced by the actual name of the user. That is the transformation. And then after transforming this data, you are going to load it into, let's say, the reporting database, another table which will be having this and this data. This is a very simplistic example. There are other things also which you do, but yes, at a very layman language. This is what you typically mean by extraction, transformation, and loading the data into the reporting database. Surajit, clear, right? I hope it is clear to others as well, just in case others also had this kind of question, but they missed asking this question somehow. Okay, so now shall I continue? I think I can, because I have answered all of the questions. I hope there's no question unanswered. Okay, so let me just continue with the remaining part here. Okay. So now we know the challenges. We have not yet talked about the solution. Okay. Now I want you guys to look at this slide for some time and then tell me what is the difference which you see from the previous slide, and then we'll talk about how did we handle the things. So your inputs, most welcome. And that's where I keep my class as interactive. I don't really go for a monologue, I go for the dialogue. Guys, your turn. What is the difference which you are seeing between this slide and the previous slide? Atul, Aditya, Raja, Surajit, others. It says no data archiving means keeping data alive, but how is this possible? Yeah, that's fine, Surajit. So I will come to those aspects for sure. What I'm trying to say is, what is the biggest difference which you are seeing right now from the previous slide to this slide? Varun is somewhere near. Varun's answer is somewhere near. All okay. Aditya gave a nice, I would say, very clever response. All the problems are taken care here. Nice. I like that, Aditya. No archiving. No data extraction. Oops. Okay. Looks nice. Looks nice. Atul says all three problems solved. Again, a very diplomatic answer. Guys, I think you missed the heart of the problem. Heart. Okay. For that, let me just go back once more. Okay. No. Hadoop usage is fine. So Surajit, you are nearby, but let me just go back and then show you something. What is it? Storage only grid. And what is it? ETL compute grid. Right? This was the previous slide. Can you see this? Don't read Hadoop. Can you see this again? I'm putting my cursor here. Storage plus compute grid. So there is no separate storage grid. There is no separate compute grid. Guys, I will come to the definition of Hadoop later. I don't want to tell the definition and explain. I want to first explain and then tell the definition. Is that clear? First difference. Are you seeing this? So you do not have the ETL layer separate and the storage layer separate. Both of them are available together. Raja, Shubhram, Aditya, Atul, everybody. Right? Is that clear to everybody? Right? how am I going to take care of the things? I'm going to explain. Okay, but first thing, that is the heart of the problem. Okay, now let me just quickly come back, and without spending much of the time further, let me tell how did we take care of these things. And I hope this kind of small case study is helping you to understand the things. You will realize it very soon when I'll go to Hadoop. Now it will be very easy for you to understand the things also. Okay, so simple instrumentation, collection of the data, this is same, but you are continuously going to add the data into the storage plus computation grid. And the best thing is, since Hadoop supports any kind of data, be it structured, be it non-structured or unstructured or semi-structured, it supports any kind of data. It can store any type of data and process any kind of data. So you are not losing any high fidelity data. Is that clear? I just want kind of confirmation at each and every point, just like I took the confirmation on the previous point. So the first point is your raw fidelity data is not lost, right? So the capturing part is taken care of, right? Am I right, guys? So Aditya has confirmed. I'm not really sure whether it is not clear to others. Shubhram has confirmed. Thank you. And I'm hoping others also. They are just kind of too lazy to type right now. That's fine. Now, let me, okay. Now, let me just go back quickly to the next part. Okay. So this is where you have every type of data storage, that's fine. Second thing is, since Hadoop supports scalability and Hadoop scalability is horizontal, it is not vertical scalability. Okay, I will explain you horizontal scalability. So, and at the same time, since Hadoop is a layer which does storage as well as computation both for you, so your storage as well as computation both are scaled horizontally by Hadoop, your problem of vertical scaling has gone away. Okay, there your problem was your ETL layer was separate and you had to go vertical scaling for that. You could not go horizontal scaling for that. It was very difficult. Okay, Hadoop, since it is providing you computation and storage together, and at the same time it is anyway horizontally scalable, so everything is automatically, horizontally scalable for you. What does it mean, by the way? So this is the right time I'm kind of, putting the seeds for Hadoop understanding. So guys, this is the main guiding principle of Hadoop, wherein Hadoop talks about horizontal scalability of the system. It typically means if you need more processing power, if you need more storage, don't upgrade the existing machine to the higher configuration. Instead of that, keep adding another machine of a smaller configuration. It is like, again, it is very, very understandable to all of you. Buying an IBM server versus buying an Acer laptop, right? Find out the difference. It should not be very difficult, right? Which is costly. So it's like the same thing. Instead of, so it's a very crude example, but this is how it goes. You have, let's say today you have to carry a certain amount of weight from one place to the other, right? And you are having a bullock cart, right? You are having a one bull who is carrying it, right? Now that guy is doing, this animal is doing this work perfectly well for you. Now tomorrow the weight is doubled. Probably you can go for a stronger bull. Good. Day after tomorrow or after some more days, your weight is kind of 100 times. So no matter what stronger bull you would put, there is always going to be a limitation. So the better solution would be either to create multiple small carts or probably add more bulls to the very same cart and then let all of them to go that way. right? It's a very simplistic kind of example. So this is what is actually the difference between a vertical scaling and the horizontal scaling. In a vertical scaling, you have certain limits, whereas the horizontal scaling, you typically go for the everybody with a smaller computing power, everybody with a smaller storage, but put together, they all give you almost kind of infinite sort of, virtually infinite sort of storage as well as processing power. Okay, so that's where that is one of the USPs, that you are talking about the low configuration machines, not very high configuration machines. Point one, right? Typically, some 6 GB, 8 GB RAM, not more than that, and the storage of, let's say, 500 GB, 1 terabyte per machine, sort of. Okay, so yes, as Atul has rightly put it, scale up versus scale out. So scale up is vertical scalability, scale out is your horizontal scalability part. So that is the guiding principle of Hadoop. Hadoop supports the horizontal scalability and the machines with low configuration, typically all of them, and they are typically called the commodity machines, commodity hardware. More on that, I will come to that definition very soon, but I hope it should be quite clear, right? So since Hadoop is providing you storage plus computation, which is horizontally scalable, your scalability problem is vanished. You are not hitting the wall right now. And the moment you are talking about you are not hitting the wall right now, it means you need not to archive your data. You can still process the data of last 10 years at one go, right? So you are not archiving your data, and hence your output, which is produced for your after your ETL process, is going to be a high fidelity. Your basically whatever trends or whatever numbers you are going to reflect are going to be much truer as compared to the previous case. Is that part clear to everybody or not? Are we all good up to this point? That's the best kind of comparison which I can do between these two things. There are various aspects. There are various other questions which might come, like okay, Hadoop is a storage grid. Yeah, so Surajit, I will recap it. So just for some senior people, if they would be interested in knowing it. So somebody may ask you, Vishal, you just told that Hadoop is a storage plus computation grid. Then what is it? You are processing it and then you are kind of putting the aggregated data back into the RDBMS. What is it? Am I right? Is it a valid question? Isn't it a valid question? That at one place you are just saying that Hadoop is a storage plus processing, and now you are processing it and then you are putting it in a separate RDBMS. Am I right, guys, in this valid question? Looks valid to you? Or do you have some specific answer to that? Right? Atul, Surajit, Raja, others, I hope you are understanding my question as well. Because typically people ask me this question, and this time it was not asked, so I'm putting it. So my simple answer of this question would be, you can ideally put all of your process data, right, basically ETL process data, right, into the Hadoop layer itself. As Atul has rightly put, putting into RDBMS is optional. Okay, you can put all of your data into HDFS, okay, into Hadoop storage. But the problem is twofold. One, there are not many BI solutions which can read the data directly from Hadoop. That is point one. That is point one. Then there are second thing as well. There are some businesses which are very comfortable in one type of BI solution only. They don't, because it is about look and feel, it is about user friendliness and all, and typically business users are very skeptical in trying out new BI solutions. Okay, so many times we are forced to do the processing, all the processing in Hadoop, and then put the process data back to the RDBMS. Okay, guys, make sense? Atul, I hope you already had the idea about it, but kind of. right? Just as a clarification. So that putting in RDBMS, and with the period of time, I think the picture is changing, like click view, tab view, and data mirror, etc., etc. There are various solutions which are, or even Pentaho is also coming up with Hadoop connectors. I heard that Oracle is also working in the very same direction. So basically, over the period of time, you might see that there are some of the connectors of BI solutions which will directly read the data from the HDFS part, and then, you know, probably this part would be removed as well. Is that clear to everybody? Now, Surajit said, can I recap this part? So exactly. Surajit, just for you. I hope you're listening. Okay. So the first thing is, since Hadoop is supporting every kind of storage, be it the structured, non-structured, or semi-structured, you are not losing the fidelity of the data. That is your first problem statement taken care of. Clear, Surajit? You need to confirm, okay or not okay, right? Then second thing is, since your storage and processing layer both are now scalable, horizontally scalable, and are together, your vertical scalability problem is gone, right? Since it is gone, right, so that is your second problem which is resolved, right? Because now you are talking about the horizontal scalability. Didn't get it. Okay. See, you are doing, so earlier what was happening? Your storage, if you look at the previous slide. Okay, Surajit. Look at the previous slide. This one. Here, your storage and your ETL were different. You were moving the data from storage to ETL. And that's where you were hitting the wall. You were going for the vertical scalability problem. Right? Are you getting me the problem statement about it? Now come to the new slide. Here you are not moving the data. Your data as well as computation both are scalable and at the same layer. Is that clear? Now that is the second difference. And since you were hitting the wall in the previous time, what was the solution which were you doing? You were archiving the data in order to avoid that problem, right? But since you are not facing the second problem, so your third problem is also gone. Now you don't need to archive the data because your storage as well as ETL processing is scaled up. Scaled out. Is that clear, Surajit? Got it? Thank you. Thank you for confirming. And that gives me the pleasure as well. You know, if people are able to understand it in this online way, that is very, you know, useful and satisfactory to the instructor as well. Okay. Now, I am not yet talking about Hadoop. I am not yet talking about Hadoop. So we just said Hadoop is equal to storage plus computation grid. That was just an indicator. But for now, you can just assume. So how is Hadoop computing? Shubham, yes, I will come to that. Let me just complete this. Okay. So what were the differentiators between the first approach and the second approach? The simple thing. The second approach is of course simple, because it is simple any given day because you are removing one layer. You are like you were having a storage layer separate, ETL layer separate, now everything is together. So your architecture is simpler, right? It is scalable because we are talking about the horizontal scalability part. It is quite accessible, right? It is accessible in the sense earlier you were having the accessibility to the data of 2 years window, but now you are having the accessibility of the data of all 10 years window, right? And then it is quite robust as well. It is robust in the sense your Hadoop is your storage plus it's basically processing layer. It is scalable and at the same time it has fault tolerance and other stuff also. So that makes this layer as perfectly robust also. So fault tolerance and other stuff, what is it? Don't worry, I am introducing these terms one by one and very soon I am going to explain them as well. But is the differentiating part clear to everybody? So simple, scalable, accessible, robust part just keep it in mind that Hadoop comes with its own fault tolerance and failure recovery part. So it makes it, it makes it robust automatically. Okay, how I'm going to cover. So Shubhram, your question is how is Hadoop computing, right? I will come to that very soon. And this would be like, is Hadoop platform independent? No. So platform independent in the sense you need Linux operating system or Linux flavor. Okay. Atul says, I have one question, need mic. Need mic means, do you want me to unmute you, Atul? I can. Sure. Hi Atul, good morning, you are on there.
Yeah, good morning.
Very good morning.
Yeah, not the question, maybe doubt. As you say, it's like the process is simple, like ETL operation and the storage in one go.
Yeah, your architectural complexity has reduced.
Yeah. So currently, for ETL operations, say for example, in Informatica is being used, right? So do we expect that will go away as time goes? People might think that, our organization might think that, okay, it's good to go for the Hadoop, even though they don't have big data, they have simple implementation right now. They have very small data, less, files are coming in MBs only, but still, it's reducing the architecture complexity, go for the Hadoop.
Yep, so nice question, and I can expect this kind of question only from, people with your experience. So simple, Atul, there are two scenarios in it. Definitely there is going to be a shift from those traditional Informatica kind of solutions to Hadoop based kind of solutions. That is for sure, yes. But having said that, it comes with some one or two caveats here, right? So you will realize it, I think, in the next class when I'll be talking about HDFS and other stuff. Hadoop is best suited for small number of large files versus large number of small files. Atul, I hope you are hearing me. Right?
Yeah.
So, so okay. So that is one of the guiding principles. So now, if your let's say analysis is still based on the large number of small files, probably people would either still be going with the traditional solution for a specific kind of analytics, and wherein they have to do some sort of analytics with huge amount of data set, they would move it to Hadoop. That is one kind of coexistence based scenario. That is one. Or sometimes there are like mandates from business, no, we want to completely do away with it. So in that case, your strategies of combining those data files and other stuff, merging them together and doing some sort of pre-processing so that you make them larger and then put it into Hadoop, that those kind of trends typically emerge. So as of now, in one of the organizations, we are kind of creating some sort of coexistence sort of architecture. Am I helping you, Atul?
Yeah. That truly helps.
Right. So this is, these trends are still emerging. So what is happening is, it's like everybody is trying to make money out of it, right? So what is happening is, there are vendors which are saying, it's like just opposite way. So there are people who are saying, okay, we will push your data into Hadoop, and they are just saying this is a specialized solution. You know what? What are they doing? They are basically applying some sort of merging solutions, and internally they are creating their own file formats and putting it into HDFS. Believe me, this is like, if I ask you to, once you are enabled, if I ask you to write this kind of program, it is hardly some 4 or 5 lines program, not more than that.
Okay, because I gone through the scenario where only structured data is supposed to be handled, but structured data is a little bit larger than the compared
right. So probably 2 years transaction data is almost 80 GB, and then creating the aggregated reports out of it becomes difficult.
Yeah, because even the end users are become impatient, like they want to get the data loaded in, have the data loaded in few seconds, and even they don't want to wait for minutes.
No. So for few seconds might not even be, Hadoop might not even be the answer for few seconds, by the way. You will realize it very soon. Few seconds is not the answer. Hadoop is not the candidate for few seconds. It was never ever designed for that way. Very soon you'll realize it. Don't worry.
Okay. Yeah.
And we'll keep talking. It's very good to have kind of your views and people like your experience. So we'll keep on having the discussions, and also if you want to continue these kind of more like industry specific kind of discussions, we can even have it like after class. So 3 hours is the mandate, but don't worry. I mean, for me it is about topics, not about time.
Yeah. Thanks.
Okay, not a problem. Yeah. So I'll put you on mute now. Thanks, Atul, for okay. So guys, I hope this discussion from Atul was useful for others as well. This was quite good. For initial, people who are starting, that might not be the relevant part initially, but you will understand it very soon. Okay. So Shubham said that it can work only in Linux or Solaris AX and Unix as well. Yes. So you're talking about the operating systems and all, any Unix and supported Unix-based platforms. Yes, it can work. It cannot definitely work on Windows. It can work on so any Unix kind of flavor. So Unix, or when it comes to Ubuntu, CentOS, and this thing Red Hat, Fedora. Any of those distributions. Okay, is Hadoop fast in both searching and storing? Okay, so Hadoop is typically called worm system. Okay, Shubham, I am hoping that I am answering your questions one by one. So either you can confirm. Okay, so Hadoop is called worm system. WORM. Write once, read many times. Okay, so now the definition of fast is something, just hold on for that. You will get more clarity about it. So definition of fast is, if you are saying fast is few milliseconds, you must have got a cue from the discussion with Atul, right? Few seconds we are not targeting. So if you say 80 GB data, I want to process in let's say 20 minutes, that is fast. But you are saying I am having 5 KB of data, I want to process it in 1 millisecond. Not possible, right? So Hadoop's limitation starts, or boundary condition starts where other systems end their condition. Is that clear, Shubham? Third question, can a classical database can be converted into Hadoop database? No. Wrong answer, Shubham. You will realize. So I will just answer at this point of time. I will just say invalid question. Okay. Explanation you yourself will understand very soon. Okay. If not, we will come back to that. I think by the next class you will be easily understandable. It will be understandable to you. Okay. Yes. So you can move the data from Oracle to Hadoop. Yes. I think 2-3 slides later I'll talk about it. Did you get the answer? Okay. Aditya says, adding to Atul's question, what kind of solutions Hadoop is offering over other technologies as Oracle and other, what edge it has over other in which it is getting more popularity? So Aditya, Shubham, both of you will get the answer in the very same slide. Okay, can I move? I'm actually approaching towards that. Sure, thank you. Now, so guys, till now, actually, see, are you realizing a pattern? The kind of questions which are coming, let's say from Shubham, from Aditya, from Atul, they are all moving to the, and most of the times I'm saying, I'm going to explain that in the few more slides and then we discuss about them, right? So that means we are like even thinking in the right direction. Your questions are also coherent, right? Now, let's talk about what is Hadoop. And then, this is for the first time I'm talking about Hadoop. By the way, we might be overrunning by 10 more minutes. So by 10:10, if we end, I hope it should be fine with everybody, right? I just hope so. Because I'm, kind of, my emphasis is not on time. My emphasis is on the concept. Okay. Now, coming to what exactly Hadoop is. So guys, Apache Hadoop is a framework. This is very important. Framework. Believe me, I have asked this question to many people. Sometimes people say Hadoop is a database. People come and say Hadoop is a language. People come and say that Hadoop is a tool. No guys, Hadoop is a framework which allows you to perform the distributed processing of large data set across a cluster of commodity machines or commodity computers using a simple programming model. Okay, now this is what I have read the line. Now let me explain. Okay, so I hope commodity computers should be quite clear. I just need the kind of responses in order to understand whether we are all on the same page. Commodity computers means computers like your laptop, my laptop, right? Now you are doing a distributed processing. I don't need to explain you what is distributed processing, right? This is what we kept on talking about, that you are processing your data across all of the machines, wherever the data is, and then using a simple programming model. That simple programming model is equal to MapReduce. So I told you at the start of the session itself that MapReduce is a paradigm, right? So that simple programming model is called MapReduce. You just solve your problems so that you can solve them in a MapReduce fashion, and then remaining things are taken care by the framework itself. Now, coming to the framework itself, okay, what does it mean by framework? So guys, framework typically means, what is a framework? Okay, what are the examples? Ruby on Rails is a framework. Struts is a framework. Hibernate is a framework, right? Why are you calling them as framework? Why do you call them as framework? There are many people from Java background. There are many people from web development background. Because they help you in doing various activities, right? So take example of Ruby on Rails. You just follow some of the conventions. You just kind of create your scaffolding thing, and then your model, then your view, then your controller, as well as database migration scripts. Everything is created by the framework itself. You just started the scaffolding process, and remaining things are taken care by the framework itself within the framework boundary. Yes, that is true, right? So all of these things are taken care by the framework itself. The same is true with Hadoop. So you just utilize the, let's say you program your code, or you code your basically whatever algorithm in the MapReduce fashion, and then that's it. Just focus on the business logic, and then how exactly that particular program is supposed to run on 10 different machines. What would happen if there is a failure? What would happen if let's say the storage is lost? So that is something you don't really need to care about. Hadoop takes care of these parts automatically. So you don't really, you focus on your business logic, and Hadoop focuses on the internals of it. So this is why we call it as framework. It provides you various things to do it, right? So you want to process the data, it provides you MapReduce paradigm. You want to ingest the data. Basically, like some time back, I think Aditya or somebody was asking that I want to get the data from Oracle, or I want to get the data, let's say tomorrow somebody says from my website, or somebody says I want to get the data, let's say from Teradata and all, right? So how do I get it? There are tools which this framework provides. They are typically called Scoop, Flume and all, right? So these are the utilities. I want to store my data, right, in the distributed fashion without knowing on which machine I am storing what data. It provides you HDFS. So just follow those commands and then store your data. Which machine, which data, where is it going, how is it copying, none of your concern. You don't have to worry about it. That's why we call it as a framework, because all of these are the utilities, okay, which are provided by this framework. And I hope you remember I skipped a slide. I am going to explain that slide now, okay. And I hope it is quite clear what exactly is Hadoop, right? And it is open source. So like its source code is available to everybody. There are Hadoop SVN URLs and other stuff. In fact, one of the assignment is also of that nature, right? You can actually access all of the data, open source code of it, modify it, use it, even you can commit it as well. Is that clear? Shubham, Surajit, Aditya, everybody, right? So I hope that Hadoop definition should be quite clear to everybody. This is basic. if somebody doesn't give me the right definition of Hadoop, right, in the interviews, I don't even select those people. In my typically I end my interviews immediately after that. Saying the same thing, users do not need to think about the distribution. Exactly. Yes. Okay. So now the key characteristics are, again, I'll quickly finish them because we have already talked about them in quite a lot of detail. It is economical, right? Because you're talking about the commodity machines. You are not talking about any industry grade hardware right now. There is some part, but only and only one machine. You will see in next session. But yes, it is economical quite a lot. It is scalable, but horizontal scalability. You talk about the reliability part. So the good thing is, in Hadoop world, the failure is something which is not unexpected. You always expect the failure, right? That is very important. So Hadoop is designed with the thing in mind that it is going to fail. Failures are going to happen, okay? And that's where it comes with its own fault tolerance mechanisms. They are transparent to you. You don't really have to worry about them, okay? And it is quite flexible. So when you talk about flexibility part, it is like basically structured, unstructured, semi-structured kind of data. You can you can access the data also in many ways. At the same time, you can process it using MapReduce or its wrappers, so it becomes quite flexible as well. Okay, more on reliability part and the stuff you will explore more when we'll talk more about Hadoop ecosystem, architecture and other stuff. Very soon it is going to follow. So guys, you remember we saw this slide some time back and I told that I'm going to explain it now. Now is the time. Okay, but before I proceed, Shubhram has a question saying the same thing. Is there any controller? No. You are talking about controller in the sense master. Yes, there are masters. We'll talk about that. Okay, very quickly. But controller in the sense of MVC architecture or the specific controller, there's no controller that way. Okay. Now, let's talk about Hadoop ecosystem. I hope many of you would have got some idea about it, but still. Okay. So you have HDFS and then you have MapReduce Framework. They are called the core components of your framework. Okay. HDFS is the storage side of story. Okay. HDFS stores your data actually. You remember storage plus processing grid. You remember? So HDFS is your storage component and MapReduce is your processing component. And these two combined are called the core component of Hadoop. Without this, you cannot imagine Hadoop. Okay. Remaining everything is optional. Right now, please ignore yarn. Okay. Why? Because I will come back to yarn in the next session or next. Okay. I will come back to yarn. And similarly, just ignore yarn frameworks. Since I'm asking you to ignore yarn, so you are going to ignore yarn based frameworks also. I will come to that in the next class when the right time will come. Okay. But right now you have HDFS, which is storing the data, and you have MapReduce, which is the kind of programming model to exploit the data which is stored in HDFS. Then I told you, right, PIG and Hive are nothing but they are the wrappers on the top of your MapReduce framework. So people who are from SQL background and the stuff, they typically like Hive, and I think probably Raja mentioned it, and PIG, as I told him, right, that he must already be working in this area. PIG is a data analysis or data flow language which is used, and again the thing is, why are they wrappers? Because, so Raja and others, you must be aware that whenever you write your script, whenever you write your SQL program, SQL query or PIG script, all of that is converted into MapReduce program in the backend. Okay, that's why they are sitting on the top of it. Okay, so for you it is a SQL query. For other person it might be a simple data flow expressed in the form of PIG script. But at the backend, essentially they are the MapReduce programs which are going to exploit the data. Okay, and then you have HBase. HBase is something which is in blue color and separate, and as you can see that this guy does not need any MapReduce to access the data of HDFS. Okay, it can access the data of HDFS directly. and that's why it becomes very powerful. It is like, it was not very popular component some months back, or I would say 1 year back sort of, but now it is gaining very popular, too much of popularity, because it has got its own strengths. It can access the data in real time. When I say real time, and update the data as well. Okay, but it has its own some related use cases. We will talk about that when we'll go to HBase. So it is not an RDBMS, by the way. HBase is not an RDBMS. It's a NoSQL database. Okay, we'll explore about that. And then, you know, Uzi. So this goes more like our, you know, course curriculum also, that we are going to talk about all of them. Uzi is the workflow scheduler. I have already explained, not as explaining much, you know, much at this point of time, but talk about these two. So somebody was asking, can I load the data from Oracle? I have forgotten the person who has asked, but I remember the question, right? So somebody, if you could just confirm, right? So see this, you are getting the answer here. Scoop and Flume, your answers, right? So Shubham, right? So Scoop is the tool through which you typically get the data from your structured data sources, and structured data sources are your RDBMS. So you want to get the data from Oracle, Postgres, MySQL, Teradata, any of these databases and others. Scoop is the answer. Just mention the right drivers and other stuff. Specify what is your source table, what is your destination in HDFS, what is the query which you are trying to run, get the data. Looks interesting, Shubham? Right? Flume. Flume is typically for the unstructured, the semi-structured data. There would be a nice article, not article, there is a nice manual which we have prepared for the data loading of some tweets, okay, from production, okay, from Twitter basically. So I would highly recommend all of you guys to do that. That would be nice. Okay, we'll be sharing it by the end of second module. Okay, so they are typically for the data ingestion part. So as you can see, this combined is called the ecosystem or the framework itself, which is enabling you to either ingest the data, store the data, process it in various ways, create the workflows, or even update the data in real time, sort of. So all of these are the possible angles, right, which you can do with data, and this is what it enables. Now a note about Yarn and Yarn frameworks. So guys, now is the time. What happens is, with first version of Hadoop, which is still used in many companies, okay, so MapReduce was the one which was responsible for the processing as well as the management of the resources also, okay. So when I talk about management of the resources, it means the memory of the each and every node, what are the mapper tasks which are available, what are the reducer slots which are available, everything was done by the MapReduce framework. But when Hadoop moved to the second level, they kind of, you know, took, since, you know, it's like separation of concerns, right? So MapReduce is responsible for processing, let it to be. And the resource management has gone to Yarn. It is called yet another resource negotiator. We will talk about that at various points. Okay, so now the cluster resource management goes to the Yarn, and due to Yarn available, you can not only run MapReduce programs, you can run any program which can follow the Yarn framework integration. So many such are like Spark, you have Storm, then you have various other you know, tools which are built on the top of it, Flink, etc., which you can now run on Hadoop, on the top of Hadoop, with Yarn coming into picture. So that's why I was avoiding Yarn. Yarn is like, it basically it was created for one, separation of concerns, two, opening Hadoop for the other systems also. Okay, is that part clear to everybody? Is that part clear to everybody? Can we just move forward? Okay, sure. Can I explain Flume a bit more? Sure. So Aditya, Flume is, again, it's a data ingestion tool. Only thing is, if you have to get the data, let's say from the unstructured data sources, let's say from a website, not from an RDBMS system, right? Then Flume is the answer for you. Is that clear? Okay, I'm now moving to the next, and I think I'm moving to the last part of it. Is that clear, guys? Aditya, I'm expecting your response. Great. So now, Hadoop core components. So guys, Hadoop, as I told you, it's a system for large system data processing, and I've already explained, so I'm not spending that much time here. You have HDFS and MapReduce. HDFS, so just a second, let me just see how much we can cover. Okay. So apart from slide number 27, we will cover everything today. Okay. Slide number 27 needs more discussion time. We'll continue the same discussion tomorrow before moving to the module 2. Makes sense to all of you? So that you should not be spending too much time at the same time, you know, it should be logical as well. Make sense, guys? To all of you? Can I get a confirmation? Thank you. Thank you. So, I told you HDFS and MapReduce are the two core components, right? So HDFS stands for Hadoop Distributed File System, and HDFS is the storage which is distributed across nodes, and you can see that node is kind of, you know, in the double quotes. Nodes is equal to machines. Machine means your laptops. Okay, so it's like it's a distributed storage across different machines. It is natively redundant. I'll come back to this point. And the name node tracks locations. Now, let me explain them one by one. So, it's a distributed storage across different machines. It is natively redundant, means the data is duplicated here. So, I told you that failure is always expected. So, what Hadoop does is, or what HDFS does is, for every data, by default, it keeps 3 copies. So you have one file, typically you will be having 3 copies of the same file in different machines using a concept called rack awareness. We will talk about that in tomorrow's class, but it typically keeps 3 copies so that if one copy is lost, it can get the data from the second or the third copy as well. There might be some people who might be thinking this is the wastage of storage. We will talk about it. It is not really the wastage of storage. The cost benefits of redundant storage is much better than the cost benefits of redundant processing. Okay, we'll talk about that later. But yes, it is natively redundant, and then name node tracks location. Now this is a new term. You thought about the nodes, right? They are typically called the data nodes. Okay, they are just holding the data as such. Okay, but then there is a specific machine. Okay, there is a specific machine in your HDFS which is called the name node. This is the master of the, so like somebody was asking, is there a controller? I think it was Shubham or somebody else, right? Or Varun or probably somebody else, right? So this is the controller, or this is the master of your system which tracks the location. So like your file is available on machine 1, machine 2 and machine 3. Okay, so the name node does not hold any data as such. It just holds the metadata. It just knows which data is where. Okay, and it is the master. So any operation which has to be done with the HDFS has to be done through name node. It also means if your name node is down, then you cannot do anything with the HDFS, right? So this is very important. I will not talk much about HDFS right now. So name node is the server node, right? Exactly, Varun. Yes. Rather than calling it server node, call it as master. That is the Hadoop-like term. Okay. Now remember, there are more points. If you remember, tomorrow we are going to talk about HDFS, so you will learn more about it. Okay. More about name node, and I'm sure some of you might be thinking that since I cannot do anything with HDFS, so name node is a single point of failure. I'm sure at least people like Atul and others must be thinking in that way, right? So just hold on about that part. We'll discuss about this thing, but it is right now from the architecture perspective. Can one data stay in multiple nodes? Yes. Shubham, that was the question. Answer is yes. How? Don't worry. You'll discover that. Now, coming to MapReduce. So HDFS is the storage. MapReduce is the processing side of a story, right? So just like you were splitting your storage to multiple nodes, this guy splits your processing across processors, across machines, okay? And it typically goes for the clustered storage, and then since it is splitting your task across different machine, just like you had the name node, you have something called job tracker, okay? So whatever program you write, okay, whatever program you are going to write and submit to your Hadoop cluster, they are going to be managed by somebody called job tracker. That is just like the master for the processing side of a story, okay? That is the master for the processing side of the story, and then all of your program is divided into multiple small tasks. They are run by something called task tracker. So task tracker are the equivalent of the data nodes. Are you getting it? On the storage side, you have the name node as the master and data nodes are as the children or are the slaves. On the processing side, you have job tracker as the master, and then you have multiple task trackers as the slaves, okay? And then there are other parts which says that near the data processing, assembling of the results, self-healing, high bandwidth. Just note them down right now. We will talk more about it in the second week when we'll be talking about MapReduce, its concepts and advantages. Okay. For now, the key takeaway for you should be that there are two components: HDFS, MapReduce. HDFS, the master is name node, the slaves are data nodes. MapReduce, master is job tracker, slaves are task tracker. Is that clear to everybody? Can I move to? So I'm basically moving to this slide, wherein actually you can see this in the pictorial form. Okay. So there are some questions. I'll answer them quickly. But before that, HDFS, MapReduce. HDFS from the storage side, you have name node, data nodes are the slaves. MapReduce, job tracker is the master, task trackers are the slaves. Make sense to all of you? Raja, I'll answer the question. But apart from this, is the discussion clear to everybody? So your question is about secondary name node. I'll come to that. I hope it should be quite clear, right? Shubhram has confirmed. I would appreciate if others also could confirm. We are moving to the last part now. Raja says, do secondary name node also do the task of name node parallelly? Not parallelly. Raja, answer is not parallelly. So now the next question would be, then how does it do, right? I'll answer that when we'll talk about HDFS tomorrow. Okay. Varun says, is it possible to have multiple masters? I mean master node. There is only and only one master in the processing as well as on the storage side. Varun. Okay. So what about backup and other stuff, right? That is something we'll talk. Okay. So I'm just putting the basics today in your mind. Okay. Now this is something which I said we'll be discussing tomorrow because it needs at least 15 minutes of discussion. It's basically what really happened with the new version. So it needs some more background, some more discussion. Okay. We'll talk about that tomorrow. But before we come to the questions, a genuine request to all of you guys that once the session is over, right, I would like all of you to fill the survey. Okay. I would request all of you to fill the survey. That is very, very important for us in order to, one, understand how did you feel about it, what was your experience. More than that, what are your needs? Is there something specific extra which we can do for you? That helps us to personalize the experience for you people as well. I hope everybody agrees to that part. That's our data collection point, right? Our BI system data collection point, right? So guys, please do that for us. Now I will go to these questions and then I'll answer your individual questions also. Aditya, yes, I will repeat. Shubhram, I will come to that part as well. Okay. Let us first, so this is right now your time to answer the questions. Okay, and then I'll answer your questions as well. So Hadoop is a framework that allows distributed processing of A, B, C or D? Shubham has given 2 answers. Quickly, guys. So, Shubham, just a second. Your first question, your first answer was correct. Then you went to the wrong answer. And please look at the definition. So, large datasets. Hadoop is also capable of processing small datasets. However, to experience the true power of Hadoop, one needs to data in terabytes or let's say late GBs, because this is where the RDBMS takes hours and fails. Whereas Hadoop does the same thing in the, not couple, basically some minutes. Right? Clear? So the answer is only one. This thing, option C. Clear to everybody, right? I hope it is helping. We have purposefully created the questions which serve some purpose. Okay, where does the scoop ingest the data from? Which of them are the following? Which of the following are the correct answers? Aditya? Others? A, B, C or D? Very good. Nice. So B and D are the correct answer. Right? I need not to explain. It is basically for the RDBMS part. It's a small activity. Please do it after the class. Okay. So these are like, you have multiple scenarios. Which of them are actually the batch processing candidates? We'll discuss it tomorrow. Okay. So this is the session summary. I think we already talked about basically the big data explanation, what exactly it is, what are the challenges associated, what are the different use cases, and then we went on to understand the basics of Hadoop, the different components, its ecosystem in depth, and then we went to understand the core components. And now this was, I think, the most about theory part, because tomorrow onwards it's going to be, I think, for after first half an hour or 1 hour, we are going to be in machine. Okay, so just be ready on those parts, and I hope you enjoyed these sessions. So we'll just continue, and remember, from tomorrow onwards the first part is going to be the let's revise part, wherein you guys would be the one who would be talking and I would not be, right? So just keep your headsets and microphones ready. Do provide your feedback, guys. I hope, how was your experience? You can anyway tell about it. Yeah, so Java training and other stuff, yeah, we are going to upload it in the LMS very soon. I think it is going to be uploaded. So we are going to send you right now, let's say, assignment and the PPTs and other stuff, either on mail. If the we are going through basically some of the rework of the entire LMS. So if it is up by today, then well, probably you might get a mail, or otherwise you will get it all on the mails itself. So as soon as the LMS is up again, with basically it is we are just customizing it for some of the things, you can easily find there. Okay, Raja, Atul, your questions were actually same. Okay. Okay, then yeah. So now, if there are any individual questions, I hope you just liked it. So basically, you can easily measure it based on whatever was your understanding at the start of the class versus whatever you are having right now. That should be a good enough indicator. And do provide your feedback, guys. Very, very useful for us, please. Okay. So if there are any questions, then I would like to take them right now. Apart from Aditya wanted me to repeat it. Aditya, you are there? Are you there? Great. So apart from Aditya, if others want to continue, you can please continue. We'll meet tomorrow at the same time, 7 a.m. So Aditya, I was talking about the Flume part. So Flume is the data ingestion. The thing is, with Scoop, you are going to get the data from RDBMS system. But when you are using Flume, you typically target the unstructured or the semi-structured data, which you would typically be getting, let's say, from different websites. Is that clear? So Flume typically, so you want to get the data, let's say some tweets and other stuff. You want to get some data from Twitter and all. Flume is the right answer. Okay. Raja says, can we import the data in Flume from social networking site with some filters and keyword? Yes. So the exercise which we are going to give you is exactly the same, Raja. Actually, we'll be giving you the exercise to bring some data from Twitter to your system. Looks exciting? Look for it. Yes, yes. Why don't? You are completely authorized to do it. Twitter provides dev APIs. Okay. Looks exciting? Aditya, was a news to you? Right? Yep. So don't worry. There are enough number of surprises which you'll see. So guys, I hope you all enjoyed the session. Thanks a lot for attending it. And now I'm logging off. I hope you just enjoyed it. Do provide your feedback. Looking forward to meet you all tomorrow. Bye. Bye for now.